Enterprise SaaS is peak for entrepreneurs and developers alike because if you sell one customer, you might get 10 new users, 100, 1,000, tens of thousands, but then you sell another customer, your business might double in that time. Now, this is also a great complexity challenge. So from a developer's perspective, it's a really cool undertaking because enterprise expects something very specific. That is isolated data. So this isolated data, this approach is called multi-tenancy when it comes to programming. Multi-tenancy allows you to isolate data inside of the same exact application. In our case, we're going to be running a single Django application, and that is going to allow us to access different databases or different isolated schemas from one another from this standard Django project. Now, all of this will be able to be built on to a pre-existing Django project itself incrementally, and that's what we want to show you. Now, there are other tools out there for multi-tenancy that make Django have that ability, but a lot of them require you to do it before your Django project even exists. I'm going to assume that you are starting with a brand new Django project and you want to add multi-tenancy as those enterprise customers come in. So what this really means is we need to have a new database or isolated place for data for each enterprise. Now, the way we're going to be doing this is with Neon. Neon Postgres makes it really easy to spin up your single database. It also makes it really easy to, divert that database into backup copies, which is called branches. So you can kind of fork the data. So when it comes to multi-tenancy, one of the biggest challenges is migrating the databases that are all associated to your enterprise customers. Think about it. If you're familiar with Django, and I hope you are taking this course, when you run your migrations, it does it on one single database. You need to do this on many different databases. And you need to make sure that you have a way to go backwards in time. Neon branching makes this process a lot easier, which we'll see in just a moment. But the idea here is you're going to sign up for Neon, you're going to spin up a database, and you're going to pay for only what you use. Yes, of course, I actually am working with Neon on this one. They sponsored this course because multi-tenancy, I think, is going to play a critical role in the future of what customers are going to need. And I would imagine Django and Neon are going to be on the forefront of that. Now, the thing about this is Neon is Postgres. So Postgres itself has a really cool way of doing multi-tenancy with schemas. So there's this thing called schema-based approach multi-tenancy, which is where we start. There's also a per database approach where you actually have an entire database server that is doing multi-tenancy for you as well. Both approaches are valid. One is far more challenging than the other, and it's going to be the one where you have multiple database servers. We'll talk about that more later, but for now, I just wanted to show you a quick demo as to what it is that we're going to be building. So here's our standard Django project. Nothing fancy about it right now. If we jump into the Django admin, we can see that there's only one user here. This is a standard Django project. This actually comes from a previous course called SaaS Foundations. We build on top of that one in this one. But the idea here is if you scroll down into this tenants thing, I can actually create a new tenant. Now, the reason I want to show you the console for this project is because if I jump into the tables, I see that there's just the public schema. If I wanted to create a new tenant inside of my Django project, what I do here is I select an owner. This owner logs into the standard console that would be a normal Django project, but then I can actually create a new subdomain. This subdomain is going to be a tenant. It's going to be its own isolated data storage. So I'm going to go ahead and save that. Now, when I say isolated data storage, I mean a new schema that's going to be created specifically for it. So what happens is our project actually runs through that process, creates a brand new schema, does all the migrations, does everything it needs to actually allow you to see new data in here. And so I just want to show you a really basic example of that new data by logging back into my users and going into tenants here. You can see that I have a demo tenant. I realize it's not fancy looking, but again, if you know Django, you'll know how to improve this stuff and make it fancy right out of the gates. And so if I go ahead and create a new user like this, and create a user called demo, I can go ahead and do that. So again, notice that the user is named demo. I go ahead and create that user. It tries to save it. if we go into our Django project and look at our users, we can see there is no user called demo. This is multi-tenancy in action. Going back into Neon, if I actually go into that tenant schema, the new one that I just created, go into auth users, there is my demo user right there. And so, of course, what I can do then is I can actually go into that tenant and go to demo.localhost. This, of course, is subdomain mapping. As soon as I go there, I see that my subdomain is true, as in it's a real subdomain. If I go to one that's not true, it says false. This is something that we cover way down the line, but the idea being that we can have individual landing pages or home pages for any individual tenant themselves. And all of that individual landing page has all of their data. So if I were to go log in, this is where I then go ahead and log in right here, and that would do all of the things necessary. Now, I've got a few things that I would need to re-engineer here, things that I actually changed to make sure that these subdomains were working correctly, but you'll see in the project how to manage all of this. The only reason that we're not seeing it now is because I really wanted to focus on getting these tenant things right so you can build it out. Now, all of the code is available right now on saasgorillas.com/code, and you can go through and see all of the code itself, everything that's currently available. I just finished it, so you can actually see everything that's coming in here. Now, a big part of this is inside of the helpers and inside of DB. We've got this schemas thing here. This is where we can check to see if any given schema is in there. We can activate the schema on a request. We can use that schema specifically within a request that's different than the standard one, or we could use the standard one whenever we want to with these public schema managers, which is a big part of what you'll end up seeing as well. So both of those things are really nice. That actually allows for us to manage our schemas and their relative users in there. So if you weren't really paying that close attention, what we saw on the actual homepage here, if I go into tenants and log into a specific tenant, this tenant is showing me a specific user, which we can also verify this user itself. So if I do ABC and just do another user in here, we can actually see that this is creating it in that new schema that is not in the standard Django project whatsoever. Doing this is about adding it to a pre-existing SaaS application. So if you already have one that's running, it's running well, and you wanted to add that multi-tenancy, this is a really good place to start for that so you can add it piecemeal itself. So I actually can go into a lot more on this, and of course, this course does exactly that. The point of this is to be able to store data isolated from other customers while also still having your standard Django project, and using this tenant schema stuff is how you go about doing that. Now, there are some things that we need to be aware of when it comes to doing this, like you can't just run this. Django has all these kinds of optimizations, so you do need to understand how all of it works before you actually copy and paste the code and go from there. So if you do have any questions, please let me know. I do highly recommend that you check the course description for all of the requirements you might need to do well in this course, because if you aren't familiar with Django, this is going to be a really, really hard course to do. Probably downright impossible because there's just advanced topics that we go into. Let's talk about the 3 levels of SaaS enterprise with Django. Level 1 provides the least amount of data isolation, that is by using just standard Django user groups. Groups are actually built into Django and a really easy way to access permissions for individual users. But of course, one incorrect filter, then you might accidentally expose the wrong users to the wrong groups or to the wrong people. So that's why it's a level 1 of isolation. Using the wrong filter is because, well, all of the user data is in one place, more than likely one database. The level 2 would be a schema-based multi-tenant approach. Now again, multi-tenancy is about using the same code, but different data storage options. In this case, that's what we're looking at here. So the schema-based approach actually takes in something that Django does by default and fractures it a little bit. There's a popular Django package that does this called Django Tenants. This is where I got the idea of doing the schema-based approach for this whole series. Now this is a level 2 because the schemas are all still on the same database server. They're not stored in the same rows or the same tables, but they are stored on the same exact server, just in a new schema. We're going to see what that looks like when we implement it itself, But if you're familiar with Django and you have a running project, you can actually take a look at your project right now and you can see that the public schema is the default that you used with Django. That will still be the default. What we're doing is going to add on to that. Now, level 3, this is quite a bit more complex to manage, as you might imagine, but that is a database per enterprise, like a database server per enterprise that runs separate from each other enterprise server. This is a lot more to manage because you might have a lot of database servers that are running with their own database schemas and their own tables. So to understand the database schemas and the database server stuff, the way I think about it is simply Google Sheets. Google Sheets as the database server, right? So if you're like normal, I'm going to spin up a Django project and I'm going to create a database, a Postgres database, probably with Neon. That's where I'm thinking here. You've got a sheet, the database server is there. Normally with your Django project, it's automatically going to create the schema for you called public. And there you now have a database or set of tables in this schema that have like users or entries or any other models that you might end up doing. So the approach that we're going to take is very similar to Google Sheets in this example, in the sense that as soon as we get a new customer, we will come in here and say something like customer A, and then we'll go ahead and create customer A. Will have a user table and a entries table as well, just like our public one. So it'd be both things, and they will be identical tables with identical table schema formats as well, or data types in all of the rows and all that. So the schemas thing, I think it's a little bit hard to wrap your mind around if you've never seen it before, which is why I wanted to show you this Google Sheets. Google Sheets being the database itself. Inside of that database has different schemas. Inside of those schemas have different tables with however many rows you end up having, which is what I'm trying to illustrate here. So the per database one is actually very similar to what you might do with Django itself. Your intuition, if an enterprise came to you, might be like, oh, I'm just going to copy my code and deploy it to another server than my main project. So maybe for your first customer, you're like, oh, I'm going to deploy this code for you on Railway or Kubernetes or directly on bare metal. You could do all of those things for that customer, but that's a fractured version of the code. It's a fractured version of the application. It's not the same, because as you get more enterprises, you actually won't be able to manage everything manually like that. You want to have it all under Django. So this takes me to the next point of all of the different definitions and discussions we can have about this. I don't want to spend too much time on these definitions or discussions. I want to actually show you what's going on. But of course, if you go to saasgorillas.com/code and click on the discussions, you will be able to see some of the definitions we're going to be working off of. The ones I just went through are basically the multi-tenant definitions as I see it for this particular course. And of course, the other one we're going to be doing is the schema-based one, because it's based off of a very popular package called Django Tenants. I'll explain why we don't use Django Tenants soon, but it has everything to do with the fact that we want to add on multi-tenancy in the future, not have to do it at the very beginning, which is what Django Tenants does as far as I know. Maybe that changes in the future, but not so far, not true. Okay, so the other thing is a few definitions I want to run through really quickly with the SaaS for Enterprise, because it's a little bit different. Now, you might be already aware of Django and the super user or the admin user that logs into the Django admin and can control the entire system. That super user is going to persist. The standard users that you have with Django are also going to persist, but they're only going to be under that public schema, that general web application that you're building out. So those things will still persist, but we'll also create another user, which I'm going to call a manager user. This manager user themselves are going to be really responsible for managing the enterprise. The enterprise will have its own console and a dedicated place to log in, a dedicated subdomain name that they will log in. This data, based off of that subdomain, is how it's going to be isolated with those schemas. You could also do this per database, which takes a little bit more work, but you could do both things in there. We actually will show you strategies on how you might want to do both things. Then we'll also have an enterprise user, which is identical to the standard user, except it's going to only be in the enterprise console. It's going to only show up in that enterprise sheet, if you will, or schema. It's only going to be in here. So like if I come into Google Docs again and say my user ABC, this user is only in the customer A sheet. It is not in the public sheet at all. That's kind of the point of that enterprise user, at least how I'm defining it for this one. So we'll still have the standard Django console, something like what we built in the SaaS Foundations course. We'll still have that same console in there. That console will just be duplicated for each enterprise customer, exactly a one-to-one duplication, and Django itself will still run both of these things. So you can actually leverage horizontal scaling, which will be great for everyone in the system. So as you start to get more and more enterprise users, you have a lot more compute behind those users. This, of course, leaves you a little bit vulnerable because if your code has any bugs in it, it might take down everybody, as in all of the enterprise customers and all of the users. So yeah, as you can tell, the way you handle multi-tenancy or the way you handle enterprise customers, well, there's a lot of different ways on how you can go about doing it. I want to show you the way that I think is really effective with Django, and even though I'm talking about a lot of things that might feel uncomfortable, I think fits in very well with everything I've ever done with Django, and more specifically, everything we did in the SaaS Foundations course, and really building on top of that to unleash this ability to work with enterprise companies and help isolate their data and their users. We're going to implement some SaaS starter code from a previous course called SaaS Foundations. This is so that we can just get started on the things that make this enterprise ready, the multi-tenancy of it all. So that code itself is available on our GitHub, which is at cfe.sh/GitHub. That will redirect you to my profile on GitHub, and then you can look for the SaaS Foundations code itself. Now, there are a few things that we need to update with this code because it did change since the course. But the course itself, we are going to be building based off of that course. It's kind of like a continuation of that course, but taking it to a whole new advanced level. Now, even if you didn't take that course, you can still do this one if you know Django, if you know how to do views, models, URL routing, and you know stuff about users. All of that stuff is required to do well in this course. You don't have to do the SaaS Foundations course, although I do recommend it. Now, the one downside of building off of the SaaS Foundations course is the code will change over time. So I am working on a managed version of the SaaS starter code as well, which you can get at git.cfe.run, as you can see at this URL here. This is going to be managed code, so I will continue to update it based off of the feedback I get from you guys. But overall, that is the two places that we would start with. I'm going to start with the open source one because, well, it makes a whole lot of sense to do that based off of everything that I've said. And of course, this actual course is free. Now, you can also get the code from the GitHub repo for this course. The actual final code will be in there, but of course, it won't be the starter code per se. It will be mostly the actual resulting code. So if you have questions about the code or things that we do in this course, go to the repo for this course at saasgorillas.com/code, and you can go into the discussions in there. You can ask questions. You can find out all sorts of things that you might need to do, which of course I probably already mentioned. So now we're going to start setting up our project with that SaaS Foundations code. Now inside of VS Code, I have already cloned the starter branch for this code itself, which of course is at this repo here. I recommend that you create your own GitHub account and your own repo and add things to it. Now, the actual branch that we start with is literally the start branch, which will give you only these three things. Mostly what we need here is the git ignore. Everything else we'll talk about in just a moment. Once you do that, you can always remove the GitHub, the Git repo folder, and then you can actually just do git init like that, and then you'll basically be starting fresh here. I just canceled out those commands. That's why nothing really changed. So once you actually go ahead and do that, you'll get your main or master branch, and that will actually show you basically that. Hopefully you already know how to do all those things, but if you don't, hopefully now you do. Okay, now what we want to do, of course, is jump into GitHub itself, and I'm going to download this code. I'm not actually going to fork it. I'm just going to go ahead and download the zip file, because this will actually correspond to how CFE Run works right now as well, or many other starter code places that you might end up using. So the idea here is once I download it, it's going to be a zip file. I'm going to open up that zip file, and it's going to look something like this. Okay, so I actually want all of this stuff with the exception of maybe the README and the license. So I'm going to go ahead and copy these and just paste in just like that. And I'm just doing Command C and Command V or Control-C, Control-V, depending on what system you're on. Okay, so the point here is our get ignore should be ignoring a bunch of stuff, but of course it's not ignoring everything. Now, before I consider this implemented, I want to actually create and make sure that everything is up to par, up to something that I can actually use. So the way we're going to do that is, of course, by implementing a Python 3 virtual environment. Now, there's a lot of different ways in how you can do virtual environments. Feel free to use different ones if you know them. And then we're going to use requirements.txt. I actually want to modify how I do requirements.txt very soon, as you'll see, but mostly with something called Pip Tools. We'll do that in a future one. Right now, all I want to do is make sure that all of this is working. So I'm going to go ahead and start that virtual environment, and then we'll do source venv and bin/activate. This, of course, will activate that virtual environment. If VS Code is opening up something saying, hey, do you want to activate this as your project's virtual environment, feel free to do that. If it's saying, do you want to open up that workspace, feel free to do that as well. Sometimes when you open up the workspaces, it automatically does this venv activation for you. And of course, we've got stuff like this, which I every once in a while need to reload, as I'm sure you already know. Now what we've got is we're going to go ahead and do our pip install -r requirements.txt just to make sure that everything is installed. Now, these requirements are very general. They're general in the sense that they're meant to be really simple to get everything up and going for your project. That's it. They don't have hard-coded versions other than maybe Django itself. But what we want to do very soon is solve that or change it a little bit. I'm going to go ahead and upgrade pip as well. And next up, what I want to do is navigate into src, and then I'm going to run python manage.py and hit enter. Now, the reason for this is I now see right away that I've got a few issues. Now, if we actually go into the code for SaaS Foundations, what we should see is stuff for the virtual environment stuff. So we got sample.env. These are all of the environment variables that we might need to set at some point. So what we want to do then is we can actually jump into our sample. Where is it? I actually don't see a sample.env in here. So let's go ahead and try it out with just simply .env. Now, I don't know why the sample is not in there. Maybe it's deleted, or maybe just when I downloaded it, it just didn't come. That's strange that it wasn't in there, but now it is. Okay, so I'm going to go ahead and copy this now, and I'll bring it into my .env. I need to create a secret key. So again, going back into SaaS Foundations, there are some commands that you can run for creating secret keys. I really like using OpenSSL. It's a really easy way to create a secret key. And there we go. So I can also do something like pb copy here and then just paste that in to my secret key. I'm not sure why it's not one line. So maybe that secret key needs to be changed a little bit. I'm going to go ahead and use Python's Django version, and we'll just go ahead and go off of that. And there we go. Okay, so now if I close this down, I should be able to see that env working. Great. So now with this in mind, I'm going to go ahead and run python manage.py again. Now, the reason I'm doing python manage.py has everything to do with what we did in the SaaS Foundations course, and that is we've got this thing called commando, and more specifically, vendor pull. We'll come back to that in just a second. So right now, I'm going to go ahead and run python manage.py migrate, as you would when you're grabbing some other code. This, of course, is creating db.sqlite3 there. And then I'm going to go ahead and run python manage.py create super user. This super user we always want to have as our super user. And of course, I'm just going in here. I'm changing the username and putting in a whatever password in here. Now that we've got that, let's go ahead and run the server. And we're going to go ahead and open up this server right here. And so there we go. So we've got our server in here. I'm going to go ahead and jump into the admin and take a look at this. And I'll go ahead and do my user that I just created, and we'll save the password and all of that. Great. So far it's looking pretty good. Let's go back into the home page here. This is not looking good. So I need to change that, of course. So let's go ahead and do that with what I just mentioned, which is that manage.py. So if I go back into source, python manage.py, hit enter, what we will see is, of course, that vendor pull, which is what we want to call here. Now, I know that on the managed code, it's going to be vendors pull, but in the SaaS Foundations one, this is what it looks like. And so now that I've got those vendors, here we go. This is great. So now if I were to log out, I should get some sort of error here. So I've got an account button does not exist. So what's going on with this? Well, let's actually take a look with going into the admin. I'll log out here. And then I'll go ahead and go back in, hit login. Now I see what the problem is. It's saying Slippers is not a registered tag library. Now, if you did the actual course, the SaaS Foundation course recently, you would have seen this problem as well. Slippers, of course, is a Python package that we now need to implement, and it's really easy to do so. First off, we're going to go ahead and bring it into our requirements.txt. I'm going to put it down at the bottom here, and we'll go ahead and run the pip install for it. So pip install-r requirements.txt, hit enter. There we go. Now we've got Slippers in there. I'm going to go ahead and go into CFE Home, into Settings, and bringing in Slippers into our installed apps, which is, of course, down here. And we'll just do Slippers as the document says. I'm going to go ahead and now run the server again. So we'll cd into the source, and then we'll go ahead and run Migrate. We probably don't need to run Migrate, but whenever I do something with installed apps, I run Migrate. Notice there's a little bit of an error related to Slippers, but that is showing us at least a good sign that Slippers is in there and it's working. So I'm going to go ahead and run the server again. It looks like the server is already running. Great. So now if I go back into my project here, I can see I should be able to log in now. It's asking me to confirm my email address. While I do think that's important to do, I'm actually going to go ahead and remove it for now because we don't have anything related to email. If you already have something related to email, feel free to do it. The point here is to get the project working so we can start building out the new features. But the idea here is we've got the email verification from Django All-Auth, which I changed. Now if I were to go into login again, what I should be able to do is just simply log in. Great. So I wanted to get to this point now, one of the things that I want to mention though is with the old Django SaaS Foundations course, we implemented the All-Auth UI. I think it's a great package. It makes things a little bit easier, but the thing is it depends on Slippers. This is a new thing that is done. Slippers I think is fine. It's generally okay, but I think it adds a lot of complexity to your project that you might not want to do. So for example, the components that you have, you can modify those individually, all individual components to have it work. And so then when you want to go load a button, you could do something like this. This to me is okay. It's not my favorite. It does do a lot of Django templating. That's pretty cool, but I actually prefer Django Cotton. And the reason for that is then with your buttons, they still look like HTML. They still look like HTML and CSS, but it just changes it a little bit. They're very similar. Neither one I'm going to go into detail here, but the reason I bring it up is because I actually would get rid of the Django All-Auth UI and just use Django Cotton instead, which of course takes a little bit more time, and it is something that I did in the managed version of the SaaS project. But at this point, what I want to say is we are now ready to go to the next step, which will be starting to understand how these Django database schemas work. Before I do that though, I actually do want to implement one more tool to make sure that our Django versions that are correct in requirements.txt and all of that is working well. When it comes to building out stable deployments, having a requirements.txt file like this is just simply not going to cut it. We need to lock in the actual version we end up using. Now, the setup process showed us exactly why. Slippers was a new dependency that was added in between the SaaS Foundations course and this one. So we want to adjust that by using something called Pip Tools. So we're going to go ahead and do pip install, and I'll do Pip Tools. I'm also going to install a tool that I created called Rav, as you'll see in just a moment. And then we'll go ahead and just do -- upgrade, just to make sure that all of that stuff is installed in our project. Now, why is it that we use Pip Tools? So now what we'll end up doing is create an SRC here and do a requirements folder. Inside of that requirements folder, we're going to do prod.in. I'm also going to go ahead and do dev.in, both of those things. So the actual requirements.txt is going to be all of the things that we just added. Dev, on the other hand, will be our Pip Tools and also Rav. So both of those things will be in there for us. So now the question is, how do I turn prod.in and dev.in into a requirements.txt file for both stages of our application? So the way this works is Pip Tools gives us a command called pip compile. This command is very useful for using the requirements.in, or in our case, prod.in, as a way to then output a standard requirements.txt file. Now, I actually never remember these commands. I always forget them. So for that reason, I created rav.yaml, or the actual rav package altogether. This rav package emulates the scripts portion only of package.json for Node.js packages or JavaScript packages. So the idea here is that we come in and do scripts, and then whatever script we want to do, like for example, install, which will allow me to run all of the various pip compile commands. And now I'm going to go ahead and just leave that out for just a moment, and we'll just go ahead and say something like pip compile. We'll fill that out in just a moment, but we'll also do something like install dev, which will also be pip compile, but it will actually do two different ones altogether. Okay, great. So the idea here then is we actually want to bring in our two different commands to run this. Now, the very first one is actually going to be this right here. So I'm going to use venv bin pip compile. Then it takes in the production file itself, and it outputs that to requirements.txt. So if we were to run this with rav, and the reason I use rav is because it's just a simple way to remember these commands. And of course, I want to run it right next to where the rav folder is. So we'll go ahead and go into the root of our project, where the rav.yaml is, I should say. We run rav, run, and then do install. What that will do is it will output requirements.txt as a brand new version locked version, right? So we'll see this in just a moment. There is our version lock. This is absolutely what we want when we go into production, so it uses the stable version that we've been working off of, right? So for example, this is Django 5.0. This is where I want to go into djangoproject.com just to make sure what version of Django is out. Hey, 5.1 is out, and I know 5.2 is around the corner. So I don't want 5.0 anymore. Now what I want is greater than 5.1, but less than 5.2. Just a simple change. I run that rav install again. This again will update my requirements.txt based off of the current version of 5.1, while all of the other versions are still being hopefully locked in place. Now, this has implications for when we deploy it with something like a Docker file, which is going to use that same requirements.txt. That's the key here, is we want to lock that in place. Now, like I mentioned before, this is certainly not the only way to do it. It's just the way that I really like doing. I like this idea of using a requirements.txt file for your different environments. So this brings me then to our actual installation process. I also want to go ahead and do venv bin and pip. Then actually we'll do python -m pip install that requirements file. So literally, whenever I need to update the production version, I can just go ahead and run the rav run install for all of that. Now, I actually want to do the same thing all over again for install dev, or my actual dev process, which again, I'm going to go ahead and copy and paste from pre-existing code that I have, which will do all of that as well. So it does the prod version, then installs that. Then it does the dev version, then it installs that as well. Now, this, of course, will have all of the things in the production version, as well as any additional dependencies I might need in my local development version, which now I can run rav run and install dev. So even if you're not using rav, these are the commands that you'll need to run to make sure that all of this is working correctly. Now, for some reason, if on Windows it's a little bit different, you might just need to test out what those commands are, in which case you would do something like win install, and you would fill out what all of those things would be and just run the rav command differently. Rav should work across platform. Now, again, this is not the only way to do it. There is other ways, like something like there's a new tool called UV, which might be much faster than this. It might be more effective. But even with rav and UV, you can still do a lot of these same sort of commands in there as well, just to have a place to remember these things and just be dedicated to only those scripts. So that's really all I'm going to talk about it at this point. If I need to update my requirements, I will go into the places where it makes sense, and then I'll run those rav commands to make sure they're working as well. Let's keep going. Whenever I create a new Django project, I always reach for Postgres, Django and Postgres integrate so well together, it's almost like they were made for each other. Now, the other thing about Postgres itself is it's actually really well suited for multi-tenant applications for two reasons. Number one, spinning up a new Postgres server isn't that hard to do. It's actually really easy to do. But then also, inside of a single database server, you can use multiple database schemas. We're going to see both of these approaches in just a little bit. But the biggest downside to Postgres itself is actually managing it. When things go wrong or security updates happen, how do you actually manage that process yourself? To me, that is far too complex or something I just don't want the headache of. So for that and many other reasons, I actually use Neon. And I partnered with Neon on this course because of, well, Neon's Postgres offering is fantastic. It's also serverless and it guarantees a SLA, if you get big enough, of 99.95%. This means that if your enterprise SaaS application starts growing like crazy, then you will definitely be able to upgrade your Neon account to handle up to 5,000 projects for $700 a month. That is 5,000 database servers, as we'll see in just a little bit, what that project ends up looking like. Now, of course, if you go beyond that, if your SaaS enterprise is just absolutely crushing, then you would go up a little bit higher than that and you can work with them directly on that. It's actually really, really nice. But of course, we're going to start with this free plan, $0 a month. That's what we're going to go off of. Now, if you want to give me credit for it, go to saasgorillas.com/db and sign in here. This, of course, will be linked everywhere as well. But we're going to be building our project based off of a Neon Postgres database. Now, the big part of this is the fact that it is serverless as well. So when it comes to building out your enterprise stuff, if you weren't using serverless Postgres, you would actually be charged every time you're trying to run the Postgres database itself. So if you had a bunch of different Postgres servers for each enterprise, that would start to add up really, really quickly, as well as just being able to manage all that stuff. It's just a lot of work. And of course, Neon will handle that for us. So inside of the Neon console, we're going to go ahead and create our project here. So I'm going to call this SaaS and Dev. So I actually want to have a different project for my development environment and my production environment. Now you can start with the database name that you might want. I'm just going to go ahead and use NeonDB. The Postgres version, well, you can use any version you want as well. I don't think it's going to have a big impact on Django itself for newer versions. I think most of the things that Django does will work with all of the different versions of Postgres, which of course feel free to use the newest one if you want. Now next up is going to be the region. Now depending on where you end up deploying this, you're going to want to change the region itself, or since we're doing the dev version, you're going to want to have it as close to you as possible. In my case, it's going to be in Oregon. Now, I would imagine there's going to be a lot more regions in the near future, but that's the one that I'll have now. The other part is the actual branches. We'll talk about this as well, but for now, we're going to use the default of main, and that's it. So I'm going to go ahead and create this project. I'm going to use their recommended for scaling, and then I'm just going to let it go. Now, the big part of this is it's basically already ready. It's not quite there, but it will be ready very, very soon. So what I want to do is I want to grab this URL here. I'm going to copy this snippet here, and I want to bring it into my .env, and we're going to call this our database URL, and I'm going to paste it in just like that. You could put quotes around it if you like. You don't really need to, but you definitely could. So with this in mind, I want to just verify that this database URL is configured in my Django project itself. So jumping into settings.py, what I want to do is I want to look for the environment variable that has the database URL. So if I do database and URL, I can see here is my database URL stuff, and DJ database URL is going to unpack the fact that it is a Postgres database and run with all of that. Every once in a while, you might need to change your database engine on here. In this case, I don't need to, but I'm going to go ahead and just mention that because you might want to at some point as well. So if you need to customize the engine, if there's this like really cool multi-tenant database engine thing that comes out at some point, you might end up doing that in there. In our case, we don't need that. So now that we've got this, I want to go ahead and close out all of my terminal windows here, and I want to run a new version of my database. So I'm going to go ahead and do python manage.py, make migrations. I probably don't have any migrations that I need to make, but you want to run it anyway. And then we'll go ahead and run simply migrate here, and we'll go ahead and see that it's actually creating a bunch of new things for us, a bunch of new tables for us. So what's cool about this is now if I jump into Neon, I can actually take a look at these tables that are being created. So the key thing here that I want to point out is this public right here. These are the database schemas. By default, it is public. So this is actually something that I want to change so we can see where we're going with the multi-tenancy, the first version of that multi-tenancy. But in here, we see all of these different things related to the Django project itself. It's great. It's really useful. But the thing is, I'm not going to use any of it because I want to change this schema. I'm going to change it all together. So that's really the first step that we want to take in the multi-tenancy place, is how do we actually just change the default schema. All right, so now what we're going to do is we are going to come into Commando here, where we've got a few different management commands that we can just use to build out our new database schema. I'm going to copy this hello world one, and we'll call this init schema.py. Mostly to test this out. Similar to the hello world one, this is probably not the command we'll end up using in the future. This is more to just see the different commands I might want to run. So what we need to do here is we need to be able to have a database connection and run pure SQL here. So we'll do from Django.db, we're going to import connection, and let's go ahead and do that. And so inside of this command here, we're going to go ahead and do our with connection.cursor as the cursor, and then we'll do cursor.execute, and we want to execute a specific command here. So this is going to be our SQL command. So in order for me to do something like this, I actually want to have a few constants for these commands. So inside of my helpers here, I'm going to create a new module called db. Inside of that module, I'll do init here, and I'm just going to go ahead and do statements, as in SQL statements. And I'm going to call this my create schema statement, or let's just call it create schema SQL. And this is going to take in, well, we want to have the .format be able to work here. We could make this as a function, but I'm going to make it a formatable string. So very similar to like Django templates in a way. But we're going to go ahead and do create, and we'll call it schema if not exists, and then the schema name that we want to use, and we'll put a semicolon at the end. To make this valid SQL, we'll actually put single quotes on the outside and then double quotes around the schema name. Okay, great. So now what I want to do then is I want to come in to my management command again, and now we'll go ahead and say something like from helpers.db. We're going to go ahead and import the statements as db statements or something like that. So now what I can do is we can come up here and give a schema name, and I'll just call this to start out. We'll just say, enterprise, or let's just do customer A. And then what we want to use, of course, is that our DB SQL statement, which of course is the create SQL DB, right? So we'll come in here and it's going to be that. And then we'll just do dot that in here, just like this. And then, of course, we'll use dot format on this. And that, of course, is going to be passing in our schema name just like that. Okay, so there we go. This will allow us to actually create that schema. Let's go ahead and try this out here. And we'll go ahead and run python manage.py just to make sure that that management command is showing up. I'll scroll up to Commando, which is the name of the app, of course. And then I'll just go ahead and run init schema, hit enter. And of course, this should give us a new schema. So inside of Neon, we can now take a look, and there is our customer A schema. Granted, we have no tables in here yet, but we do have a full other schema. We'll do the tables in just a moment, but before I do, I want to actually add in another statement, and this is going to be something like our drop schema SQL, and this is going to be drop schema if exists, and then at the very end of this, we're going to run a cascade, as in deleting all of the other data. So now that I've got this, I'm going to go ahead and change my other one to just using drop schema, just like that. And now we can run it again, and this time it should actually drop that schema. Now, you probably don't want to call drop very often, realistically, but it is something you might need to do from time to time. So that's actually pretty nice. So I'm actually going to go ahead and duplicate the init schema to drop schema, something like that. And I'm actually going to change this to example for both of them so that we can continue to work through this example and probably eventually get rid of these schemas altogether, or even these management commands altogether, mostly so we don't accidentally drop a schema when we really don't want to by accidentally running the wrong command. And hopefully you're not working on production code anyway, but overall what we've got here is now a way to create that schema. All we need to do now is activate that schema and then run the migration. The very first time we run python manage.py migrate, it does two things. One, it creates that schema in the database, the public one, the default one. Then it runs a migration where it prepares all of the database tables related to that. So if I run migrate normally, this is what we'll end up seeing after all that's all done and your database is all set up. So we want to do something very similar to that, but of course it's for our new schema. So I'm going to take this init schema portion and we're going to go ahead and duplicate that. This one, I'm going to call it migrate schema, and just like that. We'll stick with example for now. Eventually we'll have this maybe a little bit more advanced and robust than this, but for now we're going to stick with the example name for the schema. Okay, so what we want to do here is, of course, we run all of this, and then there's also another command that we can import. So from django.core.management, we can import our call command. In fact, we can also move base command up to that as well. We don't need to import it from .base. Might as well refactor if we can. And so what we can do down here is we can actually call the command, and whatever command line command we want to call, we can call it right here. Ideally, you're not calling the same command that is calling it. Otherwise, it's going to loop and it's going to time out and not work. So what we want here is we're going to go ahead and give interactive being false. We don't want this command to be interactive. This is similar to saying something like python manage.py migrate, and then -no or -no input. I think that's the one that it would be. And yeah, so that's it. That's what we're calling right there. So if I were to run it like this, it wouldn't actually make any changes to the schema default. So what that means is we actually need to activate this schema with a similar thing that we've done before with these DB statements. So I'm going to come in here, and now I'm going to go ahead and right above create and drop, we're going to go ahead and do activate schema SQL. So this means that what we do here is we say set search and underscore path to whatever schema name that is. This will come into play a lot as we want to set any given schema. So I'm going to call this activate schema SQL. And we'll go ahead and go back in here. And now it's going to be, well, similar to this, but I still want to make sure that it's created. Then I want to go ahead and make sure it's activated. And that's how we're going to go through and do it, right? And so now that we've got that, we have the ability to create, activate, and then migrate. We have to activate it before we migrate. Otherwise, it will go with the default, which of course, once again, is that Django one. So now I'm going to go ahead and do migrate schema, hit enter. And here we go. So now we should be able to see it applying all of those migrations. So one of the things that's cool about this is it's quite literally doing the same migrations that you would do in your default, the public ones, right? And if I were to, inside of Neon, I can actually drop a table. So I can drop this schema. Let's make sure we're cascading it here. So we'll go ahead and drop it. So as soon as I do that, I can run those migrations all over again, and it'll actually create them from scratch. So me dropping those schemas and cascading it actually deletes all of that data, which of course is probably a problem. More than likely, it definitely is a problem. So while this is actually working, what I also want to do is one more test just to see that it is working correctly. So we'll do from django.contrib.auth. We're going to go ahead and import the get user model. And I'm going to go ahead and declare this user model. We'll go ahead and declare it here because we probably won't use this very much. But I'll go ahead and do user.objects.create super user, and then we'll pass in the arguments there, which the username is just going to be example. And then we'll go ahead and say user A. And I'll probably need to also do user A. I think maybe we can pass in the password here. So let's try it out. I'll do username equals to that, and then we'll put in our password. equals to example 123. Let's see if that works. It might have some issues, but we will give it a shot. Okay, so we'll save this and we'll go ahead and give it another run. So what it's going to do is it's going to attempt to migrate. Migrations have already happened. If I were to run this again, more than likely now it's going to give me an error because that user should already create. Sure enough, it does. Okay, great. So we don't really need to run this multiple times. I just really want to highlight or illustrate the purpose that we're doing here. This is showing us this multi-tenant stuff. So inside of public, I want to go down to auth user. And what I should see in here is, well, no user, unless of course you created one. This is kind of interesting because, well, we did create one just a moment ago. But of course, as you may recall, it's not in the public schema, it's in the example schema. So if we refresh in the example schema and look at the auth user, there is my auth user right there with that username of example. It's in here somewhere. But the point here is that we now have a way to create isolated data just from these two things, creating a schema and then activating that schema and then running all of our standard Django commands after that, right? That's really the key here. That's what we're working towards. Now, overall, though, this migrate schema, I want to make it a little bit more advanced than this because you may or may not want to have all of the default Django installed apps. So if we look at settings.py, for example, we've got all of these installed apps. Those will all be installed by default when you run migrate, including with these different schemas. That might be something you want, that might not be. So for example, what you might want to have is maybe you only want to have some of these things in there, or maybe you want all of them. Or maybe there's specific apps that you want to have for your enterprise and specific apps that you don't want to have, like subscriptions and customers. Perhaps those don't need to be in the enterprise level, but rather just that main application that you have, the one that you maybe already have. So we'll come back to that in general, but the idea here is if all you wanted was this simple version of having your Django project, this can work and it can work really, really well. So at this point, I'm going to go ahead and actually comment out this get user model stuff. We don't really need to do that anymore, but it is really cool that you can now see and test how to store data in different schemas. This works for all sorts of things. So there is one more aspect of this that I want to show you though, and it has everything to do with Neon. Let's talk about one of the common issues that you might face when running multi-tenant apps in this way with these different schemas and all that. So first and foremost, what I want to do is I want to jump back into Neon and actually delete this project because we're going to be starting from zero just to kind of reiterate where we're at with everything. We're going to rename this project the exact same as we did before and also in the same location. So we'll go ahead and create it and use all the recommendations. We'll copy the snippet and we'll bring it on in to our .env here and save it just like that. Now I want to clear out my terminal window, so I'm starting fresh and I'm going to go ahead and jump in and run my default migration. So Python manage.py migrate, no big deal here. This is what you're probably already used to. And hopefully at this point too, you might be like, oh, well, then I'm going to go ahead and run also Python manage.py migrate and schema to make sure that that is also running as well. These things should be able to run side by side because, well, they're handling different schemas. And of course, if you go back into Neon, you should be able to see these things happening. So what we want to do though is we actually want to make a change to a model that already exists. So inside of this visits model, here are my columns. Now, of course, there's already an ID column in there, and we can verify this as well by jumping into our Neon database, and we can see our visits in here with those 3 columns. What we want to do now is simulate changing these columns. So I'm going to go ahead and jump in and grab path here, and we'll just go ahead and bring it in, and we'll call this something like subdomain, and we'll change it from a text field to a char field with a max length of some kind. Now, you hopefully already know really well that if you change models.py, you need to run at least 2 commands. Those 2 commands are going to be inside of your SRC, Python and manage.py make migrations, and then Python manage.py migrate. We run that, everything's looking good. And then of course, if I were to come in here and run Python manage.py shell, and then come in and do from visits.models. We're going to import the page visit model. And I want to just go ahead and run something simple here by doing pagevisit.objects.create, and we'll say path equals to / and then the subdomain equals to www, something like that. Great. No big deal so far. All standard Django stuff. If I go back into Neon, I can see the page visits in here. If I do a quick refresh, I can see that instance is in there. So this is where some of the issues come up. I just created a new field for this model that is in both the public and also the example schema. But of course, it's actually only in the public schema in terms of this new field. If we look at the example schema and do a quick refresh all across the board, and we now see that that field is missing. Of course, the data is missing, but the field is also missing. So this is where you might come into a bunch of issues with your project. Because if you ever forget to migrate something, well, then some of your code's not going to work. The reason I even created code is because at some point you might have a view. Let's say, for instance, our page visit view, and it's a request here, and it would be something like page visit.objects.create, and then path being whatever the path is, which I'm just going to go ahead and put in something like this for now, just to give the example of what it would end up being. And then we do an HTTP response of some kind and just say hello, right? So you can imagine this view being a part of your project. This right here is valid code for only one of the schemas. That is, the example schema does not actually have that field in the table itself, or the tables schema, right? It's missing altogether. So we have a big problem that we always will need to adjust, and we will always need to be prepared for. So going forward, the migrate schema should be the command we call for all of our migrate. So we'll have to adjust this as well. But before I even go there, what I also want to do is take a look at one of the features that Neon does so well, and that has to do with database branching. So what we could do is we could create a new branch, call it something like pre-migrate, based off of the current port in time for the main branch. And then I can also create another branch after I do migrate. So we'll stick with pre-migrate for a moment. Now I'll go ahead and actually run my migrate schema. So we'll go ahead and run python manage.py and migrate and schema. Hit enter. Now it's going to go ahead and run that migration. It's going to make all the changes. Now I'm going to go ahead and do post migrate and create that new branch as well. So now I actually have 3 branches with basically the same 3 data, but it's not quite the same 3. If we look at the main branch here, we can go into our tables and we can see now our example table that originally did not have any subdomain data. It now has that field in there. And of course, our public data should still have that field as well, which of course I need to refresh a few things, and there's that data right there. Fantastic. If I were to change the migration branch to pre-migrate, I can once again go into that example schema data in here and I can refresh, and what do you know? It's missing, as in the field is missing. So now what I can do is take this one step further and be like, oh, I actually want to get rid of that subdomain field altogether. As you may know, this would have major impact on your actual migrations that you end up doing. So once again, I'll make those migrations, and once again, I'll go ahead and migrate them 2 times. First, I'll do the standard migrate, and then I'll go ahead and do the other one, the migrate schema. So this is that main branch still, right? If we go back into our branches, the post-migrate branch was the previous post-migrate, and we can actually take a look at the tables in here. This is when it's all said and done. This is basically the most recent branch before we did the migrations. There's that page visit subdomain in there. If we look at the example, the other example one, it won't have anything. Great, looking good so far. If we look at our current main branch in here, we can now see that if I jump into the public one, it is missing that column. And all of that data that would have been in that column is now completely gone. This is where those branches are incredibly important. Now, I could continue to diagnose this and go through it, which I encourage you to do. But the idea here is this pre-migrate is the state of the branch before I ran all of those schema migrations and the state of how that data looks. It's all of that same data. So in many ways, it's something I would be able to roll back to because I didn't delete anything. Post-migrate is also one of those things that I can roll back to because it's essentially that previous data after that migration was finished when I actually created the branch. Now, there will be a time where we should probably automate this process altogether. The point of this, though, is that we can branch this at any point in time and keep all of those different schemas. Because if we accidentally deleted a schema, let's say, for instance, we came in here and we dropped that schema, right? So we come in and we ran Python manage.py and then drop schema. This is on the current branch, right? This is on the current main branch. If we go in here and take a look at the tables, we will see that that schema is gone. So if that was our enterprise customer, we would have to inform them, we just lost all of their data. It's completely gone. We're so sorry. But it's actually not, because if we go back into our post-migrate, we go into tables here, we can now see there's that example schema, and all of the data would still be in there, depending on when we actually did the branch or created the branch itself. These branches are so powerful, and I think critical for multi-tenant applications. Of course, we could be backing up our database as well. So we could do database backups as well as these different branches, as well as branch-based backups too. So we can do all sorts of things over time, which I think is really compelling. Now, the key thing about all of this, though, has to do with how we're going to do those migrations going forward. So realistically, this migrate schema here would not just be on the main schema migration, but rather it would be multiple of them. So basically, I would want to do my schemas now being example, and then like our public schema here, and then we would actually come through, tab this over, and do something like for schema and name in schemas, and then iterate through each one every single time we want to do our migration so that our public schema for sure is migrated, as well as any of our sub schemas. Now, you might imagine where this could also come from. This could also come from the public database as well, which we'll take a look at in the near future. This, of course, is still fairly simplistic, though. We still have some things we might want to expand for our tenant schemas altogether. So the other thing about this is maybe we don't want the public schema to be here, but rather we run it beforehand. So like something like this, where we come up here and do our same cursor. This time we come back and we give the schema name of simply public, and we do this one first before we do all of the other sub schemas in there as well. And once again, we can bring it in as migrate, right? And so we could do it first, we could do it separate. It doesn't actually matter the order so much as the fact that we now have a bunch of different options to make sure that if we have problems with migrations, which you certainly can, super easy to do. It's super easy to accidentally not have something like a subdomain field and run all those migrations. This one single management command will now help us all across the board with doing those migrations. So now going forward, what we want to do is actually expand how we do these migrations and not just be a general migrations with every installed app, which is something we still need to look at. Now we want to have our customer-only apps or the enterprise-only installed apps. These are going to just be slightly different from our standard project. That standard project is still going to work exactly as you might expect. So the idea here is I want to create a new module with these installed apps. So I'm going to go ahead and copy this, and we're going to go ahead and do installed.py, and we'll paste this in. So the first thing that I want to do is something like my default apps and bring in the default apps that you might want. For example, the Django apps, all of the Django related things, maybe even the Django admin you're going to want to bring in, and then probably all of the third-party apps as well. Now, a big part of the reason you would want all of these third-party apps is if any of the templates need to use any of these third-party apps, they can. So that's a big part of why we do this. And so now if I were to just say installed apps like this, this is still the same as it was before. This time though, I'm actually going to change it from installed apps to underscore installed apps. And then this is what we're going to use in our settings. So instead of installed apps like this, we're going to go ahead and just come in and use the underscore installed apps, which of course we need to import. So we'll do from.installed import, and we'll put it into parentheses like that. Great. Nothing has changed so far. They're basically all the exact same, which of course we could verify by running our different migrations. So if you run migrations now, it's going to do all of the same stuff that it was before, but this time it's just separated out a little bit. So what we really want to do is, yeah, I've got my installed apps, but maybe I also want to have my customer apps. So I'm going to just go ahead and copy that one and just call this customer installed apps. now I can decide which apps are going to go in to my enterprise customers, right? And this can be all of these. They can be all the same ones, or it could be none of these. So what's going to end up happening, or what is going to inform this, is how closely related these apps are. So for example, the subscriptions app, I think, might have something to do with the customers app. So if we look into our models here, we really just want to see if there's any imports in here related to the other thing. And I actually don't see any. So there is no foreign key relation to it, right? There might be at some point, but there's not right now. So I can probably be safe to say that I can get rid of the the subscriptions and the customers, and really just have profiles and visits. That's it. So those are going to be my customer installed apps at this point. Now, in the future, I might have to change these things. The point here is what we end up installing. So I'm going to go ahead and import that, and then I'm going to scroll on down to my installed apps, and I'm going to do something for customer apps, and it's just going to be that right there. Or maybe we call it customer installed apps like we did over there. Okay, great. So now we've got these two items. So back into our migrate schema command, this actually might be getting to the limit of what we want to do in a custom management command. We might want to actually turn this into a helper function, but that's outside the scope of what we want to do right now. What I actually want to do right now is change this migrate command, how this command ends up working. My standard public schema totally can still run migrate, can still run everything we did before. This call command here, I can actually call something like one of the installed apps. So I could do something like profiles in here and literally just run those profiles. So for right now, I'm actually going to comment out the migrate on the public schema just so we can see the customer schema ones and just really focus in on that only. So what we see here is it's actually only running the schema based off of the profiles. It's not doing everything in there. It doesn't show me that it's not doing everything, but it's literally only doing everything that's in that profiles app. Versus if I get rid of that and run it again, it will actually migrate everything as it shows right here. So what I want to do is I actually want to grab the import for the correct installed apps, these ones right here. So I'm going to go ahead and do that with the imports themselves. So we'll go ahead and do from Django.conf, we're going to go ahead and import settings. And now we're going to go ahead and say our customer installed apps equals to get attributes, and we'll use settings of that one. And then we'll just go ahead and use an empty list as a default. So with this in mind, I can now say inside of this call command here, I would just go ahead and do something like for app in those customer installed apps. And then I could try something like this. I can save that and run it, and what I'll end up getting is an error. There's no installed app with that label. So this is actually not how I'm going to be able to iterate through them. I'm going to have to do something slightly different than this. And the way this is done is by using Django apps. So we do from Django.apps, we can import apps here. And so what happens with Django apps themselves is we can actually iterate through. Instead of doing the customer installed apps here, we can do apps.get app configs. And now I can actually see all of the apps. So I can print out what the app is. So we'll just try that out to start out first. I'll comment this out. We should only see print statements of all of the different apps. Great, so these are the installed apps that are on there, right? And that's going off of the installed apps declaration, not the customer installed apps one. So to make it based off of the customer installed apps one, what we get here is we're going to go ahead and get our, let's say for instance, our app name, and this is going to be grabbing the app config dot name, right? And so now what we can do is say something along the lines as if app name not in the customer apps, this right here, then we can go ahead and hit continue, right? And so now we'll go ahead and say something along the lines of, customer app and app. So let's go ahead and do that. We'll save it. I'll run this again. And now what I should see is a few less apps in there. Most specifically is subscriptions is not in there as it was down here. So that's one of the ways we can go about doing this. And then what we just need to do is we need to run the call migrate command again, now for the app, and then app.label. And that's really all we need to do there. So I'm going to go ahead and save that and run it again. Now we're actually going to run into potentially another issue. What it's doing is it's going app by app. It's not actually doing like literally everything that's in the installed apps, but we now get this problem where this app does not have migrations. So there's a couple of ways on how we can solve this. First off, I can just put it into a try block here, and we can just do accept and continue. So basically, if it doesn't actually have the ability to migrate, we can just go ahead and pass over it with that accept and continue, which I think generally speaking works okay. So we're running through here, we see all those different migrations, and then it skips these ones, and then it finally finishes off all of the ones that are available, which takes a little bit longer than the standard migrate command, but overall it does actually do these different migrations. So the nice thing about this is down the line, you could actually start logging this and be able to diagnose migration issues as they happen for any given schema, right? Which is also pretty nice. This is not nearly as advanced as it could be, though. We could make it far more advanced than this, but I think overall, this actually works really well because now I have two settings for my installed apps. One are going to be my general apps, my standard installed apps. The other one being my customer installed apps that are very specific to that customer. Now, a lot of times your actual installed apps you might actually want to have and include your customer installed apps and make sure that they are in there. In which case, if you ended up doing something like that, you might want to turn the installed apps into a set. So plus, or equals to the set of the original installed apps and just turn it back into a list of installed apps as well. The ordering here might actually end up mattering, so there is some things that you might want to think about in terms of a caveat of that. So if you were to run Migrate now, it should actually work just fine with all of those apps. It also might work just fine without the list and set, but here we go. We've got those duplicates now, so perhaps you don't want that. So now what we've got here is maybe we get rid of these default apps and we just have customer apps and then all of that. And then it just goes and gets rid of all of the defaults so you can still run the standard migrations as you might. As far as I know, the actual ordering of these apps doesn't matter. This is not where it matters. The place it matters is inside of the middleware, which brings me to my next point. If it is required in middleware, you're definitely going to want to bring it into the default apps. The customer installed apps are more like our internal apps that we might want to support or maybe not. Anytime you bring it in middleware and it needs to be an installed app, just be aware that that's the case, right? So for example, the Django all-auth, it's in middleware. We want to have it in both places. We definitely want to make sure that it is there and available. This, of course, doesn't necessarily have implications on how it works for any given schema, at least not how we have it set up. It's really just about the database itself. It's not so much of the functionality of things like middleware. The installed apps is still where that is going to be a key part of all of this. Cool. So now that we've got this, I'm going to show you a more advanced look. I'm just going to copy and paste it. We'll go through it so you can see what that advanced look looks like. Taking a look at our code at saasgorillas.com/code, jumping over into commits, and then looking for the commit of advanced customer schema database migrations, and actually going into the browse repository at this point will allow you to see the code we're going to use, and I'm going to go ahead and discuss it a little bit here as well. So what we want to do is jump into commandos, into my management, commands, and then finally migrate schema. The one we just completed is in the Migrate Schema Basic. I'll probably leave it there. The Migrate Schema.py will certainly evolve over time, but let's take a look at what it does right now. First off, we have the ability to skip or actually run the public schema migrations. This, of course, will allow you to ensure that your Django project is running as needed, and then also eventually you could turn it into arguments for this command line tool. Then, of course, we have a list of schemas, which eventually will be based off of the database itself, the public database or the public schema. Then we're going to go through everything just like we did before in the basic one. But this one's a little bit different. The first thing it's going to look for is whether or not this schema exists. If it does not exist, it will go ahead and create it. If it does exist, then it will go ahead and just activate it like it did before. So it's not a get or create anymore. It's now checking if it even exists in the first place. After exists, this is where the difference comes in. We now want to make it look a little bit more like you might be used to when it comes to doing migrations. So if I actually went ahead and ran this right now, I'm going to go ahead and run it here. This is what we want to see, is something a little bit more like this, which you might be used to in your standard Django migrations. But actually going through this step by step was just very cumbersome. So I just went ahead and just gave you the code altogether. once you run those migrations, it then looks a lot more like what you might expect with the standard Django migrations. And that's what's happening here. We've got an executor and then a actual loading build graph that comes up. Then we've got all of our customer apps, the same as we did before. Now it's just iterating in here. Then we actually go through each one of those customer apps. We build out the graph that we want to display all of the nodes that are going to be migrated and all that. Then it goes step by step and does all of the different migrations as it needs to, like we saw before. That's really it. I didn't really want to go through all of this because it is tedious and something that I worked on with an LLM. So it just happened with AI to make this actually work really well. And we have to come back to this in the future because of how we actually will implement our schemas in the future as well. But the point of this was really to just have some sort of reference that you could just go through into the code. And the way to do that, of course, would be to go into the migrations directly. So if you go into the main branch or you're starting in the main branch, you just go into those commits and you can actually see the repository at that point, or you can actually take a look at the changes that happened if you're curious about how much it changed. It did change a lot from what we just did, but the point here is to have something that gives us a little bit more of an advanced schema migration, at least advanced in the sense of what we see. The previous one, the basic one, still works really well. It's just very basic. It doesn't actually cover the things that we want. And the new one is quite a bit faster, actually. It ends up working a little bit faster for all of our different schemas. But the thing is, this migrate will not be how we end up doing it in the long run. We need it to be based off of database actions, which is something we'll work towards as well. But before we work towards that, all I really want to have now is the ability to access the different data. I want to be able to view it in my view. So I need to start building out all of the features for that to work and to work correctly. But this migrate schema we will need for now going forward, and we will continue to maybe evolve what schemas are hard-coded in here before it's all automated. I want to test out subdomains in development. There's a lot of different ways on how you might approach doing subdomains, but most of the time you can actually just use localhost, not 127.0.0.1 like the Django project here, but rather just using localhost. This should work on all of your projects. So if you were to add a subdomain here as like cfe.localhost with the port still, hit enter, this will give you this disallowed hosts because, well, this is a security feature of Django. So what we want to do, of course, is activate that. The easiest way to activate it is by going into your settings.py and then just adding a period right in front of localhost on allowed hosts. Now, there's other things that we might need to do to make sure that this is working correctly, but the main thing here is that it actually renders out just like that. If yours renders, then you're probably ready for the next step. If yours does not render, that means that you probably need to update your local systems host file. So the way you do this is if we do cat and then etc hosts, you can see that I have a bunch of customized local hosts on here. You can also see the default that's on there as well. And so if you were to want to try something different, like in my case, I have desalsa.io here, I can actually point that to my Django project, still using the same port though. So in my case, this desalsa.io, if I hit enter, this says disallowed host again. This actually blocks me from going to that actual domain. It will not try to access the internet version of it. And so once again, I can actually come in here and bring in desalsa.io, hit a period right before that, and I refresh and there we go. So this is a domain name that I just use for development all the time. I don't actually go there. Of course, if there was a project that ended up coming out and it's great and it's called desalsa.io, I would probably end up changing it. But the idea here is the way you change this is really simple. We just do sudo etc sudo nano. Let's go ahead and clear this out. We'll do sudo nano and then etc hosts. We hit enter, we put in our user's password, our super user's password, and then we type out the actual values that we want to go to. So go to .desalsa.io. We save that, restart. We also might need to restart our machine depending on what machine you're on. And if I do go to .that, I now have these subdomains. So the idea here though is we will be using localhost. Most of you will probably not need to actually write out a other domain, but I will want to test out that other domain at some point for the domain extension. Now what we need to do is actually grab what that subdomain is and then activate a schema based off of that subdomain. Let's take a look. Now that we can use these subdomains, it's time to create a custom middleware that will activate the schema for us based off of the subdomain that's being requested. It's actually going to be very straightforward because we've already seen how to activate a schema. But the idea here is we need custom middleware. Now, in this case, we want the middleware to run before any database actions occur. So I think the best place for this would be after the security middleware. We actually already saw the security middleware with the allowed hosts. We want to make sure that that is happening prior to trying to activate any sort of schema at all. So with this in mind, I'm going to go ahead and actually use a custom middleware after that one. Now, of course, I need to create some custom middleware, and it's actually fairly straightforward to do. Inside of helpers, we're going to go ahead and create a new folder called middleware. Inside of this folder, we need to make an init file, and we also need to make something like schemas.py. Now, I'm calling it schemas because it's our schemas middleware. That's really the point of it. You can call it whatever you'd like, and you can put it pretty much anywhere you like. I'll show you how that works in just a second. So the idea here is if you go into the Django documentation, you will find this class for simple middleware. You could use the function-based version as well. I find the class-based version to be a little bit more straightforward with the things that we're trying to do here, but both of them work great and they work the same way. They're just defined differently. That's all. So with the middleware here, I'm going to go ahead and paste in this simple middleware, and I'm just going to call this the schema, activation middleware or something like that. Actually, we'll just call it schema middleware. That's probably fine, or maybe schema tenant middleware. Great. So with this in mind, I want to now install this. Now, the cool thing about this middleware itself is it can actually modify a request and a response. So it does it every single time. This is hit on every single request and response cycle. Anyone that's there, as long as it's installed. Perhaps you know this already, but if you don't, hopefully you do now. The idea is inside of views.py, we've already seen this request response cycle, but it's only on a particular URL, right? So when you visit the about page, in this case, it's wrapped in with the URL. If we go in here, we can see there's the about page. It goes to the about view, which is defined right here. We've got a request, and then we also have a response at the very end. The middleware works the same way. We've got a request coming through, and then we send back a response. The difference between a middleware and a view is the middleware is called on every URL, every path that's there. It's always going to be called every single time. So let's go ahead and bring this in then in our settings.py into our middleware. Once again, we want it right after the security one. I'm going to go ahead and do a simple way to grab this is first off, I'm going to copy the relative path to the module itself, and I'm going to go ahead and paste that in here. So it should be fairly obvious on how to change this, but first off, we get rid of the src and we just change these slashes to periods, and now we're getting that dot notation going. And then of course, I need to change .py to the actual class itself that we're going to be using, just like that. Very straightforward in terms of installing middleware. So with this in mind now, what I want to see is these printed request response going on with my project. Let's just make sure that the server is still running. Sure enough, it is. We will look in that console in a moment. And I'm going to refresh on this page here. And there we go. We see our request and we see our response. So this response right here is coming from the view. So more than likely, we actually do not want to touch that response. So I'm going to go ahead and just leave it like that. In many ways, I could probably just save it like this and just call it a day. So now it's a lot more like a view itself. And keep in mind, we could still do all of these same things in a view as well. If you wanted to change the schema activation process into a view, you totally can using the same methods we're about to do. So first and foremost, we need to actually get the subdomain itself. The way we do that is by doing the host, which is request.getHost. We don't need the path at all, although you could build this same idea based off of the URL path that is coming through. So something like /abc or let's say /cfe, you could actually activate the schema based off of that path as well if you wanted to go that route. I think the subdomain makes a lot more sense because of how enterprise login would probably end up working. But what we can see here is we can print out the host itself. And once we refresh on here a few times, you can see there's the host. It's coming through. It does not have the path on there at all. It's just simply not necessary. Now, if you wanted to know if it's HTTP or HTTPS, you can also just print out request.scheme, and that will actually give you HTTP or HTTPS depending on what is going on. In this case, maybe you want to require HTTPS before you activate any of your enterprise software. That might be something well worth doing in production. It's not something I'm going to do right now, but I wanted to point it out because, well, maybe if it's an insecure request, you don't ever want to activate any of your enterprise customer data, any of your tenant data. Maybe you will be okay with it with your own project, but even then you'd probably want to require HTTPS. That's a different discussion than what we're trying to do here. Instead, we're really trying to focus in on the host itself. Now, one of the things we can do in here is we can get rid of the port on this. So if I did host portless, all that means is we go ahead and do host.split on the colon there that comes in with the host itself, the actual port itself, and then we grab the 0th element. This should actually split it into 2 pieces here. And so now I can actually see host portless on there, and that should give me a portless host. Okay, so one of the things I want to try right now is just to make sure that this works with a domain name extension like .com or in our case .io. So basically changing this to desalsa like I did in the last one, just to make sure that this is working correctly in terms of, let's spell it correctly, in terms of the actual domain name itself. So we should be able to get the same exact host in here just like that. Great. So both of them are working. Now from this host portless, what I want to do is split it up. So host split, and that's going to be based off of the periods. So if I do split and then, not enter, but rather dot period, now I can see the split up host itself. We'll refresh that again, and once again, I can now see, let's try that again with the save. I should be able to see it all split up there. Great. So the 0th element should be the subdomain, but every once in a while it might not be. Let's go back into localhost so we can see that one, and that's what we're going to be working off of. But the idea being, there we go, we've got goto and localhost. Now, if I get rid of this subdomain, I should have a single length, and that is going to be the localhost itself. Great, so now I can use that value, and we can say something along the lines of a default. We'll go ahead and say subdomain equals to none, and then we'll say if the length of the host split is greater than 1 now, we could then say what our subdomain ends up being by grabbing the 0th element of that host split there. So if we copied that and hit 0, then we actually should see what our subdomain ends up being. So we're going to go ahead and save that, and let's go ahead and give this a shot by actually using a subdomain with .cfe.localhost, and sure enough, there is our subdomain. So everything's all split out. Now, this might fall apart when we actually go into production, but for now, this is just fine. We'll use this to activate our schema. So the next part of this would be to come down here and do something like define set search path, which will take in a self and schema name, and then we'll go ahead and return something in here. We probably don't need to return anything yet, but we will do that in just a moment, and basically saying something along the lines of self.that and the schema name. And then from our schema, from our subdomain, we will need our schema itself. So we're going to go ahead and define get schema name, and it's going to take in self and then subdomain. So we'll actually put the default of subdomain being none, and then we'll go ahead and say if subdomain is none, return maybe public, the default schema that there is. We can also then say if subdomain equals to, let's say, for instance, local host, then we can go ahead and return back public as well. We can also then say if subdomain, or rather, let's go ahead and say something like if subdomain in desalsa.io, then we can return that as well. Or maybe, for instance, we could say if subdomain equals to desalsa itself, then maybe we also return public. This, of course, would be your actual domain name of some kind. I'm just using desalsa as like a placeholder value for what that might be. Otherwise, what I'm going to do is I'm just going to go ahead and return back public as well. So then the next part of this would be something like if subdomain equals to CFE, then we'll go ahead and return back our CFE schema, which is going to be what? Well, maybe example. So we'll probably need to bring that one back in, but the idea now is we have this get schema name, so we can do the self.getSchema name of the subdomain that we actually have. I probably won't need to actually print anything out now, but what I will do is print activate the schema, and we'll go ahead and bring in the schema name right there. So let's go ahead and save this out. Let's go ahead and make sure everything's running correctly. I refresh on here. What I now see is activate the schema, and it is blank, which is odd. So let's go ahead and see why it's blank. Maybe we didn't actually pass in the schema name or get it correctly. Let's see back in here. This should give us that schema name, and it looks like it's not. So let's go ahead and say print schema name up there. And let's try and refresh that again. There we go. Activate the schema example. Maybe I just didn't save something correctly. But there we go. So now we have the ability to eventually activate this schema name. Let's go ahead and get rid of some of these print statements in here. We don't need them any longer. So now what I want to do is I actually want to activate that schema. We already know how to do this. Going into Commando, into Management, Commands, and Migrate Schema, or Migrate Schema Basic even. We already did activate it right here. Now we also created it. This is not where I want to create it. I will want to check whether or not it exists, most likely, which is something we did in that more advanced one where it's like, hey, here's to check if it exists. And then here is to check if it does exist, then you can activate it. So both of those statements, or this whole block, I'm going to go ahead and copy here. And I also want to copy the, not necessarily the whole block, but the definitely activate search path part here. So what I'm going to do then is we're going to come back into our, our schema activation part. We're going to paste this in here, and we need to do a few imports here. The first thing is if it does not exist, well, we don't want to do anything. So I'm going to go ahead and just say, we're going to come through here. Actually, I might need to activate the public schema altogether. So let's go ahead and try this a little bit different. I'm going to tab this back. If not schema exists, then the schema name is going to be simply public, which will exist. Great. So let's go ahead and do some of those imports. I'm going to go to the very top here, which is going to be this one and a few of the others. So we'll go ahead and now bring that into our schema activation. I really only need the DB connection and then the DB statements in there as well. Okay, so if not schema exists, if it doesn't exist, then we want to go back into the public and handle it on that front in some form. And then we will just return back nothing because we don't really need to return anything. Okay, great. So this should work, or in theory it should work. So let's go ahead and give it a shot. First off, we got CFE. This hopefully activated our schema. It says activate a schema example. This also assumes that that schema exists. So if we come into our database tables here, I actually don't have that schema existing right now. So let's go ahead and bring it back with the Python manage.py and migrate schema. Hit enter, into SRC there, and then run that. It's creating the example A, so it's not the example that I'm looking for. I'm actually looking for just simply example. Okay, let's try that again. And once again, it's going to go ahead and create those schemas. While that's running, what I want to do is I want to go into my local host, and then I'm going to go into the About page. Hit enter. I get this template does not exist. That's because, well, the About page from the starter code did not give me a whole lot. But if we look at that About page with the About view, so if we go in our URLs, here's the About page, the About view, we can see that it's attempting to create something here. The template is incorrect, so I'm just going to go ahead and do landing and main. I believe that's the landing page template that we have. So if we go into our landing page, which was definitely done in the SaaS Foundations course, here is that landing page template. Now I should be able to actually render something out on this home page. So if I refresh for this a few times, it should be on the public schema. So going into the public schema for the page visits, we should be able to see all of these page visits come through, and we should see a bunch of new ones come through in here as well on our different pages. Great. So now what I want to do is just jump over into the example schema, refresh everything in there, go to that page, and I see that there's nothing in here, right? So now I actually want to see something in there. I want to actually try out this schema. Let's see if all of this works. Going into the subdomain here, going into that About page, refreshing here a few times, going into our console, refreshing, what do you know? there is that about page working. Let's go to the home page. I think that also will register that as well. Going back into our console, I refreshed the home page twice. What do you know? We now have two different schemas that actually handle the data very, very differently. And so it's now isolated the way we want it. There's still some work that needs to be done to make sure that this is well, organized for the entire project and actually not all hard-coded examples like the example schema that we have right here. This right here needs to be changed. And realistically, what we could actually check is if the subdomain is in, and then actually go, or if subdomain in, none local host and de salsa, then we would just return back public. We don't need all of these. We can just see that. Great. So that makes it a little bit easier in terms of activating the different schemas on here. And so again, you could test this out as much as you like. The reason this page view one is so nice is because it gives us a really simple way to test out all of the instances that are coming through. Now, you can also test out the admin. One of the challenges right now is our example schema doesn't have an admin. There's no real way to log in yet, and there's no admin. So that's definitely something we will need to worry about or implement. But right now, this is the key of all of this, making sure this middleware works and that we can activate this schema when it does change or when it is being accessed a little bit differently for that particular user. It's really, really cool. Now that we can map subdomains to activating a schema, it's time to actually turn that into an actual database model so that we have a lot more control over it. The main thing here is eventually we will automatically generate a schema name and have that managed by the public schema itself, and then also have a subdomain which will be able to be changed. So let's take a look at the model that we want to build for this. We're going to go ahead and jump into the SRC folder. We'll run python manage.py start app, and I'm going to call this tenants, mostly because this is a multi-tenant application. You could think about this as enterprise, but I'm going to think about it as tenants, so it's very specific to the multi-tenant stuff. It's not just general enterprise things. So let's go ahead and create the baseline of this model. So the first thing is we're going to call the model itself tenant, so it's going to be models.model, and we want to think about the fields that are going to come in through here. The very first field is I want to actually override the default ID field by using a UUID field. Now, the reason for this is so that the tenants aren't going 1, 2, 3, 4, 5, but rather just having a UUID that will come through and actually define the ID for any given tenant. Now, the tenants themselves will not be managed inside of the actual tenant application. It will only be managed in the public schema in our standard Django project. So I'm going to go ahead and import UUID here, and we'll go ahead and bring in the default for the UUID field as simply UUID and UUID4. We're going to also make this our primary key being true, DB index also being true, and then we also want to say something like editable being false. Okay, great. So what we have now is just a simple tenant model that will also need a owner of some kind. And this, of course, is going to be a foreign key to a user. And what I want to do is if that user is deleted, we probably want to set this to null. And I'll go ahead and say null being true. Now, the reason I want to set this to null is because eventually we will have a schema name in here that we definitely do not want to absolutely lose or have the possibility that it's lost. So with this in mind, I'm going to go ahead and do from Django.conf. We're going to import settings, and we'll go ahead and do user equals to settings.auth user model, which of course, as you may know, defaults to the string of auth.user. This is just so it's reusable if you ever do change the default user model, which is something you might be really interested in doing on these enterprise level. We'll talk about that a little bit more when we start using users on the schemas themselves. So the next few fields are going to be hopefully fairly obvious. First off, we're going to do our subdomain field here, and there's going to be models.char field, and it's going to be a max length of, let's say, for instance, let's just do 60. And then that's pretty long for a subdomain, and we probably don't need it even that long. But I'll go ahead and say unique being true, and then we will need validators in here, which I'm not going to do just yet. So leave that as is. Next up, we're going to do a schema name. Now, the point here is I want to make sure my subdomain and my schema name are separated. The subdomain will be the subdomain, of course, for the tenant, like cfe.localhost. And then the schema name is going to be how we store it in the database. Right now, I think it's just example. So we want those to be separate so that the actual tenant can change their subdomain without affecting their schema name. So with this, I'm also going to do a max length of 60. This is going to be a lot more required. I think the maximum length right now for Postgres for schema names is 63, but I'm going to leave it at 60 to just give me a little bit of extra wiggle room if I need to. I also want this to be unique, and I will also go ahead and say blank equals to true and null equals to true. And then our subdomain, I actually am going to go ahead and bring in the DB index in here as well. So I want to have indices for 3 different fields here, so subdomain and schema name, based off of how much we're going to be looking those things up based off of those values. Schema name we might not look up that often based off the value, but definitely subdomain and ID. So next up, what we want in here is we want to declare on whether or not this is active. So we'll go ahead and give it a default value of true, and then I'll also go ahead and say active at, like a time when it was activated, and I'll give a date time field here and do null being true and blank being true. Now, the reason I have this active at field is if I were to toggle this, then it becomes inactive, which maybe you want to keep that as well. So we can go ahead and copy this and say inactive, something along those lines, so you can just see whether or not this tenant is active. Just a little bit different than what you might do with a timestamp in an updated field, which both things I'll just go ahead and copy and paste, and these will be auto set at the database level. Great. So with this in mind, let's go ahead and actually build out the active and inactive fields here. I'm going to go ahead and bring in from Django.utils, we're going to go ahead and bring in the time zone 1. And so basically what I want to do here is we're going to define save, and it's going to be self, args, and keyword args. And we'll just go ahead and say if self.active and not self.active at, then we'll do self.active at being time zone. Let's go ahead and actually just bring in, I'll say now equals to time zone.now, and we'll do that. Next up, we'll do else if self.active and, or not self.active and not self.inactive at, then self.inactive at now. Okay, so this is just mainly for the toggle itself, which also means then if this is active, then we would say something like self.inactive at equals to none, and then down here we would go ahead and say none as well. Hopefully those are fairly obvious on how that would toggle and save everything, and then I'll just go ahead and do super and then .save and args and keyword args. Great. So now we've got our tenant model. Things are looking pretty good. We still need to, of course, create the subdomain and the schema name. Both things we still need to have some validation on, and the schema name will have to be created in the very near future. So with this in mind, I'm going to go into CFE Home, into installed. Now what I want is in my installed apps, remember these are the default installed apps, so the Public Schema default installed apps, and then my tenant / enterprise apps. So in the default installed apps, this is where we're going to go ahead and bring in our tenants application itself. So we'll go ahead and save that. With this in mind, I also want to go ahead and just check a few things out. So we'll do from.models, and then we'll do admin.site.register for that tenant. And let's go ahead and give this a shot. We'll do python manage.py, make migrations. And then we'll go ahead and python manage.py migrate. And let's see if our server is still running. It looks like it is. So what I want to do is I want to go back into localhost without activating the CFE schema. That subdomain, I'll go into the admin here. I don't actually think I have an admin user, so let's go ahead and create one. And we'll jump into the SRC again, python manage.py, create super user. And I'll just use the defaults that I've got with a whatever password at this point, because we're really just still testing things out. So logging into the admin here, I'm going to go ahead and jump down into tenants. And all I really want to test right now is that I can actually add these things. So the owner is CFE, and then I'll go ahead and say CFE as the subdomain. Schema name will come back to, and then we'll go ahead and leave this active. I'll hit save and continue. Hopefully what this does is put active at. If I change that from active and hit save and continue, now it should say inactive at. Great. So now I've got timestamps for both of those things based off of that toggle. Now, one could also argue you could just use the timestamps as the Boolean values. In other words, if you were to set active at, that means that it is active. If you were to delete it and put inactive at, that would mean it's inactive. I just like this toggle of having that Boolean value, and you can just track when those things happen. Great. So now we, of course, need to actually generate the schema, and we also need to make sure that our subdomains are valid, like we need validation. So when it comes to our actual users that will enter this information, we will just allow them to pick a subdomain that matches what they want for that enterprise itself. We could probably even give the tenant itself a name, but it's also not necessary because basically when they create a new tenant, when they're an enterprise and like, hey, I want to go ahead and create a new enterprise, tenant itself, they would just pick the subdomain. That's it. That's the only thing they would pick. Active would be based off of their billing and all that. That's kind of the thinking there. Now we're going to go ahead and bring in a simple function to create our schema name for any given tenant. So inside of these tenants here, we're going to go ahead and do utils.py, and we're going to go ahead and define something like generate unique schema name. And I'm going to pass in the tenant ID being a string in here. You also might pass in a instance itself of the tenant, right? I'll talk about that in a second, but for now, we'll just go ahead and just do this. And what I want to do is I'm going to go ahead and give a base name equaling to the, we'll do a string substitution here, and we'll do tenant underscore whatever that tenant ID ends up being. So the tenant ID, of course, is going to be based off of this tenant model itself. So this base name is probably fine, with the exception that what I need to do is I would actually need to replace out all of the dashes with underscores. UUIDs have dashes in there altogether. And even that, I could probably just squish them all together and use something along these lines where it's not as long as it needs to be. And then we would return back the base name up to a max length of some kind, which we said 60. So that might be another argument you bring in here as max length and an integer equaling to 60. Now, it can actually be longer than that, but I like 60 being the round number versus 63, which I think is the limit for Postgres. For some reason, it's 63. I'm interested to know why that might be. Okay, so this actually should be unique because of the tenant ID. This would also be true if the tenant ID was one, it was like sequential, the standard, ID that you'd have in here. This would still work for both of those things. Now, one of the bad things about this is then we can actually look at our schemas when we go in. We would be able to look at our schemas and we'd be able to see exactly what tenant with the ID. This may or may not be something you want in there. Maybe you don't want the actual tenant ID as part of it. Maybe you want this to be a little bit more secretive or even more unique. So one of the ways we could do that is we could create a hash. So we can actually do import hash lib, and then we can actually change this base name here by changing it to a hash and suffix. And there's going to be hashlib.sha256. We're going to grab that base name. We're going to go ahead and encode it with UTF-8. Then we're going to do .hex digest, and we'll go ahead and go up to like 16 characters here. Then we've got our original base name, which will be, well, we'll call this now our new, let's say our unique name. And this is going to be equal to our original base name up to some count, let's say, for instance, up to 40 characters. Then what we just do is we use this suffix in here as well. So basically we do our schema name being equal to the unique name. So we'll put that in the first part of this, and then the suffix with an underscore in here on the second part. And then once again, I will come in and do our replacing, if there are any replacing needed for our schema name, and then we can return that. Right. So this whole part right here, not necessary. It is something that you can definitely do if you wanted to hash it a little bit more. I'm going to leave it in there just so we have the more complex version that, kind of hides the tenant ID from the schema name itself. So they're not always correlated. But realistically, in the public, model, the public database, we have the tenants in there. So being able to find out what that schema name is going to be fairly obvious because it's going to be in here right there. So it's not going to be that hard to find if for some reason it's leaked. So it's not necessary, but if you really want to generate a unique one, or you decided I'm not going to use the UUID field, I would just want to use the 1, 2, 3, the sequential fields. In that case, this would then be required. You would definitely almost want to have this. Now, the reason I mentioned the instance before, so let's say, for instance, you brought in the instance in here and set that equal to none. What you could do with the instance is you could then get the class from it and do instance, and I think it's class like this, and then you could actually check out if that even exists. So something like class.objects.filter, and then the schema name equaling to, let's say, for instance, this is our final name, which we'll leave in here like this. Then you would be able to come in and see if this exists, if qs.exists. Then you would have to change some stuff and just rerun this. Now, I've done this actually a lot of times with slugs, unique slugify fields. Now, I probably won't need this for this schema at all. Mostly because we've got our tenant ID here, which is a UUID field. Then we create a hash based off of that. Then we combine it again with the original one. I think we should be absolutely fine with this schema name and generating uniqueness. Granted, it's something we could always test, but I'm going to leave it out for now. Next up, what I want to do is I want to bring this in. We'll do from.import utils. And now we're going to go ahead and say something along the lines of if not schema name, if not self.schema name, then self.schema name equals to utils dot generate unique name with self.id. I think we did. Yeah, great. And we don't really need anything else. I'm not going to use that instance. I'll get rid of that. Max length will stick at 60, and there we go. So that should actually solve that for us. I shouldn't have to run any migrations, but one thing I want to do in order to test this is we're going to go ahead and do our tenant admin now, and it's going to be admin.modeladmin, and then we'll go ahead and actually bring in the, we'll say read-only fields being the owner, or not the owner. Let's go ahead and just leave in just schema name. Let's see if this is enough. We might need to put more things into our tenant admin. We also might want our timestamp in here. Let's go ahead and bring in the timestamp and updated, also active at and inactive at. There we go. Okay, so let's see if our server is still running. Hopefully we have no errors there. It looks like we're good. Let's jump into the admin again and refresh in here. And there we go. So now we've got an empty schema name in here. I can't edit it at all in the Django admin, which is something I want to keep. Inactive, if I hit save and continue, this should set two things. The schema name, there it is right there, and then the active or inactive at. Okay, so great. Now if I were to make it active, the schema name stays the same. It shouldn't change at all. Assuming that we did the save method right, it almost looked like it changed it. One of the problems that I have with this is that there is still the underscores in there. Perhaps you want to keep them, perhaps not. I'm going to keep them in there because we can leave underscores in with our schema names. These tenant subdomains, I'm going to allow the tenant themselves, the actual user, to be able to change them. So with that in mind, I want to have validation built in at the field level, not just at the form level, but at the field level itself. It's a very straightforward validation. One is just making sure it is a actual subdomain. Two is to make sure that we aren't using blocked subdomains, for example. So now what I want to do then is I want to jump into my helpers module here, and inside of DB, I'm going to go ahead and create something called validators.py. Now you might be wondering, why is it that I'm using helpers module for validators versus what I did with the previous one for generating the unique schema. The reason I'm putting the subdomain in the helpers is because the subdomain validation can be used in a lot of projects. Generating a unique schema is very specific to this particular model, although it could probably go into the helpers module as well, but I'm going to go ahead and leave them just like this. Okay, so the first validator, I'm just going to go ahead and copy and paste for you so you can see it. It's using the subdomain regular expression that actually just checks to make sure this is a valid subdomain. That's fairly straightforward. Hopefully you understand how to do all of these things. Even if you don't, I'm going to show you a very simple example now. So what we also want to have is something like define blocked, or let's say, for instance, validate blocked subdomains. Yep, let's spell it correctly, and there we go. And we bring in the value. Okay, so what I might want to have is something like our blocked subdomains or blocked names. And I'll go ahead and come in here and do something along the lines of maybe CFE, maybe admin, maybe www, maybe just, blocked, and then all other kinds of spam names you might want to block in here. So this is, I'm going to call this a blocked list. And so inside of my DB here, or maybe even inside of my helpers, I'm actually going to turn this into its own module. We'll go ahead and do security here, and I'll go ahead and say blocked lists.py, and we'll go ahead and bring that in there. So I'll go ahead and create an init file here and do something along those lines. So then we bring in this blocked list here, bring that in here. This, of course, you would probably want to expand a lot. This is not a whole lot going on here, but I want to bring in at least some sort of blocked list here. So we'll now do from helpers.security.blockedList. We're going to import the blocked list here. And so all I really want to do is see if value in blocked list, then we'll go ahead and raise that validation error, similar to what we did in the subdomain, but now we'll go ahead and say it's not a valid domain. Something along those lines. That's it. That's all we really need. We could add more to it, I suppose, but the other part of this is maybe doing something along the lines of value equals to value.lower, something along that lines to lowercase it to make sure that everything in the block list is accurate. And so we could also then go through that process as well, making sure the lowered blocked list is in there as well. So x.lower for x in that blocked list also. So if it's in that blocked list or it's in the lowered version, which maybe then we actually come through here and have a full-on thing and do .lowered. And now we just use that blocked list here. So the value will be checked in both places. Great. Yeah, so now that we've got this, we've got two different validations that we can use. So going back into our models now, we're going to go ahead and do from helpers.db.validators. We're going to go ahead and import both of those ones. So subdomain and then validate block subdomains. So with these functions, they're very simple. All we need to do now is go into our subdomain here, and I'm going to go ahead and separate this out so it's a little bit more clear as to what's going on. We can now do our validators being equal to those two validators. And we can just copy them like that. And there we go. So now, of course, it's going to just make sure that anytime this is saved, those validators are triggered, and they make sure that, it's not in the block list, and it's also not in one of the, that it's actually a valid formatted subdomain itself. So with this in mind, I'm going to go back into my admin here. Notice that there is a CFE one. I put that in the block list. If I hit save and continue, this should say now it's not a valid subdomain. Great. So when it comes to a block list, you also might do a regular expression block list so that it's not, CFE one doesn't work or something along those lines. I'll let you kind of handle those things now. And you could build out those validators a lot more if you need to for whatever reason. Another thing is you could always audit this, because these are enterprise customers. If they use a subdomain that you just don't approve of, or maybe you have a blocked one that they just want. Like for instance, if you're going to come in here and do something like Apple, and then Apple's like, hey, we want to be a customer. Well, yeah, you'd probably allow them to be Apple. So of course there's ways to override that and make sure that that's working, and it's something that you would have the ability to do. But the point here is we definitely want to make sure that we are validating this stuff, and so that they're not putting in gibberish in here and saying, oh, that's my subdomain. That can't happen, right? That's the key part of this, because it's all going to be user generated, and this has dramatic effect on the rest of the site itself. Now that we can actually create subdomains and a related schema to it through the tenant model, we need to go ahead and migrate that schema, make sure all of those tables are in there. Then we also need to go ahead and activate it. Both things we're going to do right now. Now, what's probably not surprising, and this actually means that we need to jump into Commando here, into Management, into Commands, and then Migrate Schema. So we already have some of these schemas in here. No surprise at all, right? So what we want to do is we want to change this to be based off of our now tenant models. The way I'm going to do this is by using the apps import here. Now, the reason I'm using apps is so that eventually when I change this handle command into its own function, then we will see exactly why I'm using apps at that time. Mostly it has to do that we're not overlapping with anything else. Okay, so the schemas that we want to use is going to be based off of our tenant model. So we'll do tenant equals to apps.getModel, and it's going to be tenants and then our tenant model. So the app name and the tenant model. If you've never seen this before, this is just so you don't have to directly import the tenant model itself. This is a little bit better way of doing that when you are worried about circular imports, which I am. I don't want to have circular imports when I'm doing something this important. That's why the actual model class is being handled in the function itself that's handling it. Okay, so now that we've got that, we now want to do our query set. Well, what is going to be our query set in here? Well, first off, our query set itself actually needs to be based off of the public schema, right? So this cursor command in here, we actually need to bring in. We need to make sure that we are calling this based off of our public schema, because that's where all of the tenants are going to be stored. So I'm going to go ahead and bring it in here. That activates everything. So this query set should be in that public schema. Very important that we do that correctly. Now this query set here is not all. We actually want to filter it by active being true. That's a very important part of this. So we can actually remove things as we need be. Now, I'm not going to drop any schemas here. That's actually not something I'm going to handle automatically. I'm going to let you handle that manually. So when a customer leaves, you don't accidentally delete all of their data. We want to make sure that we're still storing their data. So if they go inactive, that's going to be a manual deletion process. So you know for sure that you want to remove it from your database. Now, the important part of this, though, to keep in mind that using Neon, when it comes to these schemas, or even if you have multiple projects, the serverless of it all, it doesn't really cost you that much more to store that data. Granted, if there's a lot of data in there, it might make a lot of sense to delete it, but we'll talk about, kind of handling that a little bit more later. So what we've got here now is a query set that will have all of the tenants that are active. So all we need to do is change the schemas to be based off of that query set, which we can do with values list. And all we need to grab is the schema name and then flat being true. And I'm also going to turn this into a list itself. Okay, there we go. So this might be the way we go about doing it. This will actually flatten all of the schema names, or what you might want to do is actually just go through a loop on the query set itself. The efficiency of this is going to be, well, not great necessarily. If you have a lot of tenants, you're not going to want to run schema migrations every single time. So we're going to need to solve that at some point too. But for now, what I'm going to do is I'm actually going to change this from listing out all of the schemas to basically being, hey, let's grab our query set in here, and now we'll go ahead and do our tenant object, and now we'll go ahead and grab our schema name from that tenant object. So this is actually a good grounds to being like, oh, this is going to be a function we want to separate out later, because now it's going to be very specific to the actual instance itself from that tenant object, whatever that might end up being. Great. So now that we've got this, let's go ahead and jump into Neon, and we're going to delete our example schema. Let's go ahead and drop that and cascade it. That will delete everything, of course. And then we'll go ahead and drop the example A as well. Dropping both of those, great. And if I refresh inside of here, I've got a subdomain of CFE1. I actually want CFE as my subdomain, so I'll go ahead and get rid of that one and the block list, and we'll come back into the admin and just change it to CFE because this is coding for entrepreneurs. So yeah, let's use that subdomain. Okay, great. So the schema name did not change. So now when we go to run our migrations, which I want to do, we'll go back into the SRC folder here. We'll run our python manage.py, and this is going to be just simply migrate schema. It probably should be schemas at this point, but we'll stick with migrate schema. And there we go. So we can't adapt tenant using placeholder. Okay, so we've got some issues in here with the actual query set lookup, most likely. Okay, so what I want to do then is come back in here and let's just go ahead and just print out the schema name. I see the problem already. This should be .schema name, and that's it. That's a really easy fix. Feel free to test it out on your own, but clearly it's saying cannot use type tenant as a placeholder. It should be text. That's how I knew it's just the object. It was very, very obvious. Hopefully it was to you as well. Now that I run this, it's going to go ahead and run the schemas. These warnings, again, slippers, we can ignore that, but now it's going to create that schema for that tenant. Looks like I don't have any issues so far. We can jump back into the Neon console, do a quick refresh in here. There is that new tenant. Great. And so if we come in here, nothing's in there so far, but something can be in there very, very soon. I want to show you a challenge you might face when it comes to using schemas that are now stored in our database. Let's remember the public schema itself is where this data is stored. Now, this is actually very obvious if you go into the Neon console, you refresh on the different database schemas you have. The public one has tenants in there. If you were to change to any of your tenant ones or your enterprise ones, the tenant table is just simply not in there. So this is actually a very easy thing to make a mistake on and why we need to improve how everything works. Now, one of the ways that we can test this really easily is by going into the schema tenant middleware and try to activate our schema based off of this subdomain, based off of a stored entry into our public schema. So let's go ahead and see what this looks like. So first off, I'm going to go ahead and do from Django.apps. We're going to import apps here. And then we're going to go ahead and scroll all the way down to this get schema name. Now I'm going to come in here and just do something like the tenant model. And there's going to be apps.getModel. Now, once again, I'm using apps in this case, so I don't have any circular imports at any time if I ever need to reuse this somewhere else. That's kind of the point. And so now I'm going to go ahead and do tenants and tenant, of course. And now I'm going to go ahead and grab my object, which is going to be from tenant.objects and .get subdomain equals to the subdomain that's being passed into this. And then we're just going to go ahead and return back obj.schema name. Now I realize this might cause issues if the object does not exist. I'm not worried about that just yet. Let's just see where I'm going with on this one. So we do have a subdomain that does exist, which we can see in the Django admin. The subdomain is CFE, and here's that tenant itself. Again, we can verify in our database that that tenant exists now, and we can also verify that it has no page visits. So as soon as I go into localhost on the home page there, hit enter, I should get a page visit. If I were to change the location, let's go ahead and try that, or a refresh. In my case, I accidentally refreshed it, but there we go. We get this programming error. Let's go ahead and try and change location. Let's see if we get that programming error this time. This time I didn't. If I refresh again, I get it again. What's happening here? This is one of those things that might actually happen as soon as you start using and mixing the database schema data. So in this case right here, what's it attempting to do, what our logic is hey, go into the public schema and grab this data. That is where the logic is. Do that every single time I need to get the subdomain schema. But of course, it doesn't actually work that way because what we end up doing is we grab our subdomain schema, then we activate it. We also check if it's there, then we go through and activate it if it exists, right? If it does not exist, then it'll go to that public schema and then it'll do all of the things it needs to do. Now, part of the reason it's failing or it does refresh has to do with the fact that this is causing an error, which I think then leads it to actually activate the public schema again. So if we didn't have that, maybe it still wouldn't work. The point is not to figure out what's going on with the schema tenant middleware, but rather to highlight one of the things that definitely might happen in your project if you're trying to mix and match schemas that aren't mix and matched. This is also painfully obvious. If we go into installed apps here, we have specific customer installed apps and specific public schema installed apps. So the tenant apps themselves, these are going to be the only ones we end up using. Now, what this also might do is if you're familiar with Django and familiar with something called reverse, this actually could cause a lot of issues as well, because in our, tenant schemas, it's not going to have all of the same installed apps. So if you try to do something like reverse and, tenants, and then, some argument or something like that, or tenants list, if we had that list view, which we don't, this will cause errors inside of your other application for very similar reasons. Now, it might actually not have that big of an impact, which we'll test and see if it does, because this right here is more of a code thing. It's not always database related, so that's something to keep in mind as well. But the idea here is as soon as we activate a different schema, everything going forward is going to use that schema, not the default one. So any sort of database lookup would be in the new schema, not in the database one. So we actually need to change this. We need to change how we activate any given get schema name based off of any given, schema that we might end up using. So we're going to go ahead and take a look at how we might go about doing this inside of our middleware. The way we're going to do this is by creating some reusable functions. Let's start that right now. We want a way to temporarily use the public schema. Mostly so in our middleware, we've got this get schema name. We have a way to temporarily call the public schema and then bring back some data as we might need. Now, the way I'm going to do this is inside of helpers, inside of the DB here, I'm going to go ahead and create schemas.py. Now, I realize calling it schemas might have some confusion with the middleware one, but to me, I don't think it's that confusing. Feel free to change the names if you want to, but I'm going to leave it in as database.schemas. So what I want to do here is I want to create something like use the public schema, and pretty much that's it, right? So how are we going to go about doing this? Now, one of the ways we want to do this is very similar to what we've seen before. So like activating this public schema like this. So I'll go ahead and copy that, bring it on over in here, just like that. And of course, the schema we're going to use, we don't need to check whether or not it exists because the default is going to be public. So we're just going to go ahead and do something along these lines. Naturally, I need to do some imports here. So I'm going to go ahead and grab some of the imports I already have in here. And there we go. So now we've got this use public schema thing here. Now, one of the parts of this that we need to do is I want this to work a little bit differently than just a standard function. What I want it to be is with use public schema, right? And then do something like tenant.objects.all. Now, I could also turn this into some sort of function as well, but for now, I'm not going to do that. Instead, what I'm going to do is I'm going to turn this into a context manager. So the way we're going to do that is with context lib, we're going to import the context manager, and then I'm going to go ahead and just use that decorator here. As soon as I use that decorator, I can do something like this. But the part of this that I need to update is the yield statement. So I want to go ahead and bring in yield here on the same line as with. Okay, so the statement itself, I'm going to go ahead and just change this a little bit to being our, we'll just call this our default schema, something like that, and it'll just be public. And so that's what I'll now use down here, and we'll get rid of that. Okay, so we want to actually have a try block for this, so I'll go ahead and do try, and then we'll say something like finally, and then I'll just go ahead and print out something. We'll talk about that in a second. Okay, so now we've got this use public schema that in theory will work the way we're hoping. So now back into our middleware schemas here, I'm going to go ahead and now bring in that value, and we're going to go ahead and bring in from helpers.db.schemas. We're going to go ahead and import our use public schema function here. I'm using the absolute import for a reason. I think it's just a little bit cleaner in this case, especially because the module names are the same. So now I'm going to go ahead and do with use public schema, just like that. this will allow for me to get that data. And so then I can actually bring in our schema name. This time I'm going to leave it in as simply public. And then basically if that data doesn't exist, then we'll see it in a moment. And then we'll return back that schema name. Great. So now we've got that use public schema. Let's go ahead and make sure that we have no errors. Looks like we have no errors now. If I were to refresh on this about page, I should be able to use it every single time with no errors. And what we should also see is the visits themselves. Those should be incrementing correctly now. So if I go to the home page, it should increment it one time to that home page and then go to the next one and so on and so forth. Great. So that's a really good start to how we might want to use the public schema itself. Now, there are things that are hopefully fairly logical in terms of, hey, is this the most efficient way to do this? Yes and no, right? No, in the sense that we probably want to actually have a fallback to the original schema that's working. No, also in the sense that, do we really want to do a database lookup every single time we go to the subdomain? The answer there is no. So we actually do need to implement things like caching to make sure that this lookup doesn't happen over and over again. The other thing, of course, is we also want to put this into a try block. So we have a try exception in here. This is a very obvious one in this case. So tenant does not exist. Then we'll go ahead and print out, or we'd probably want to log it at some point, but we would say something like the subdomain does not exist as a tenant or something along those lines. Okay. And then otherwise, we'd probably have some other exception in here, and we'll just say as E, and then subdomain does not exist as a tenant, and then also put the E in there as well. And we'll just put it on a new line. There we go. Okay, so if the tenant doesn't exist, then we've got that error. So let's go ahead and try that out with something else like ABC. That tenant does not exist. The page still renders because the logic for the page still renders, but we see that ABC does not exist as a tenant. The view itself does not change based off of what's activated, not yet at least, as far as the subdomains or anything like that. Maybe at some point we'll need to, but for now, the point of this is just to make sure that we're using the correct tenant when it actually is the correct tenant, when it's actually the correct subdomain and the things that are activated for that. Now, do keep in mind that if you are using just the public one, this will also have implications on the visits that are there, right? So if you go into abc.localhost here, this will actually store it in the public one, and you can see that right here. So this might be a good time to bring back that subdomain thing that I mentioned before, or even the request host, so you can see that in those visits table. That's something you can definitely play around with. Now, one of the things about this new schemas database model is it actually leads me to believe, oh, maybe I should expand all of the schema related activities to be just in this single module. That, of course, is something we want to do. We want to build this out so it does everything related to the schemas, including connecting to our new one, checking those things, maybe even creating new ones, but mostly checking whether or not it exists, and then also activating it if it does exist, otherwise doing the fallback. So there's still some refactoring we want to do, but at this time we have a way to actually, at the very least, use our public schema, which I think is great. Let's keep going. So inside of this use public schema, every once in a while you might want to revert back when this is all said and done. So this finally thing here is how you would go about doing that. So let's say, for instance, something like revert schema name being none, and then revert schema being false, right? So by default, we're not going to attempt to revert it at all. So one of the things about reverting it is, perhaps you would do something just like this, where you bring it in and you go ahead and use that revert schema name. And then basically you could say something along the lines of, if revert schema, then you can go through and essentially activate that schema reversion. Now, the thing here is we want to make sure that that schema actually exists. So for example, if you delete a schema, you want to make sure that it exists before you try to revert it. Otherwise, some errors could happen. So the way we then want to do this portion, or more specifically the activation portion, is we now want a function specifically for that. So we're going to go ahead and now define activate tenant schema, which will take in a schema name, and we'll just start with that. And of course, this isn't that big of a deal because now we can just use something along these lines like this. And we'll just pass in the revert one, and there we go. So now we've got that function that can basically handle that same thing like we did just a moment ago. And there we go. Not a big deal. But the thing here is it's not actually checking whether or not that schema even exists. So how do we actually go about checking it? We've already seen this a couple of times, but here's that function right here. This is how we can check whether or not that schema exists. So going back into schemas.py, we can now check if schema exists with the schema name coming through and then passing in and basically saying something along the lines of exists being false, and then changing this schema exists to just simply exists, and then we can return back exists, whatever that value ends up being, assuming everything is tabbed correctly. Okay, so this is nice that it checks it. Now, this isn't the only way to check it. You could also do it another way, which is basically if this actually fetches any data, so is not none, then we can just say that it exists. That's probably fine. We don't necessarily need the Boolean value there. Okay, even though they're basically doing the same thing. So now that we've got this, we are now checking whether or not it exists. It actually makes sense to come up here and now say if that schema exists, then you could go ahead and activate it. But realistically, if it does not exist, we want to use the default. So I'm going to go ahead and do something like schema to use being, well, the default schema, right? So by default, we'll say that it is that one, and that's going to now be the schema we use. If it does exist, the schema to be used will be the one that we pass. Great. No surprise here. Not that big of a deal. All around, it's fairly easy to do. The next real big thing is, do we even need to check whether or not it exists? Well, let's go ahead and say that. Is check exist required or exists required? Well, let's just check if the schema name is not equal to the default schema. No big deal, okay? Or whatever. But I want to leave it in as default schema, even though I said it twice, just so it's very clear as to what's going on here. And basically all I would need to do is say that and that. So if the check is required, and then we check if it exists, then we change it, and so on and so forth. Otherwise, this will just default to using the public schema. Now, this might be where we decide to change our mind about the default schema statements, because now they're being imported in other places. So in here, I might actually want to keep these standard statements going through, in which case I'm actually going to do. The only reason I didn't do it before was because we were kind of reusing these statements all of the time. And so we want to make sure that we're doing that. And so this is going to be the statement that we will use inside of this activate one here. And I'll use the F string itself. So I'll go ahead and just say SQL statement or SQL equals to that. And then there we go. This is, I think, a little bit cleaner to work with than what we were just doing. And I also want to probably do that down here as well with that same thing. I realize now we are repeating ourselves in here, but I actually think I prefer this way, so it's very clear as to what the SQL is that's being used. And this one should be that default schema. So we'll go ahead and say schema to use equals to default schema again, and there we go. Okay, so easy enough in this case in terms of how we activate things. Now, one of the other things is this check if schema exists. Well, we now can just go ahead and say if the schema name equals to the public schema, we're just going to go ahead and assume that that exists. The reason we would assume that is because this function most likely would not be running if that public schema does not exist already. Of course, we could always require it to be tested or something like that, or we can do require check in here being false and not require check or something like that. There we go. Easy enough to then now check all of these different things. Great. So with this in mind now, we can actually go back into our middleware and be like, oh, well, we want to activate the schema in here. We don't need any of these statements anymore. Now I can just use the activate tenant schema statement in here. So go back into our middleware. We're now going to bring that activate tenant schema in here, which will then come through, and we can get rid of all of this, hopefully, and just do our schema name. Now, right away, you might be like, oh, well, we probably don't need both of these things anymore, and we don't. So I'm going to go ahead and just bring that right up here and get rid of this set search path but rather just go ahead and activate that schema name as need be. So of course we need to test this stuff. Let's make sure that it's working by going back into our project here, into ABC. This should be the incorrect one. That should go into public, and then CFE should go into CFE. So we can check that on the public one. We got a new entry in here as I refresh. And then of course in the CFE one, I'm gonna go ahead and refresh. Looks like it maybe did a new one. Let's go ahead and just do another new one in here just to verify, and we can refresh again, and sure enough, there it is. Okay, great. So now these functions are a little bit better. Now, you might think, oh, we can refactor in all the places, and of course you could. I don't want to do that just yet. I just want to stick with this and get all of this working correctly before we might want to refactor stuff. But it is a good challenge that you could do right now, as in the Migrate schema. And here, there's a bunch of different things on how we could go about actually activating and refactoring in here. One of the big ones would be to create that schema. Maybe this should be in there as well in terms of the functions. But I'm going to leave it like this for now, and we will continue on. Now, one of the questions we need to answer is, what is the current active schema? Do I really need to activate a new schema if I don't need to activate the schema? So that's what we want to actually solve now. The way we're going to do this is by creating a wrapper for our database engine. So inside of our helpers here, we're going to go ahead and create a folder called engine. Inside of this folder, we're going to make two Python modules, the init file and also the base.py. Now base.py is required, as we'll see in just a moment. But the idea here is from Django.db.backends.postgres. We're going to go ahead and import base, and then we're going to go ahead and create a class called database wrapper. This has to be named database wrapper, and it takes in base and database wrapper. What do you know? We are overriding the default value here. And so all I'm going to do is add in something called schema name and set it equal to simply none. So what I want to do then is I want to be able to set this schema name. So anywhere I need to know what the current schema is being used, I will be able to do it. So the way this is going to be done is by going into CFE Home, into its settings, into your database configuration settings. You're going to go ahead and pass in the engine here, and this is going to be helpers.db.engine. You do not need to do .base or anything like that. It will default to that. Now, the key part of this is we are using Postgres, so we want to use the Postgres backend. If we were using something different, you would want to use something different and update that accordingly. So once we do this, what we can then do is inside of where we activate our schema, this right here, we can now go into our connection and add in our schema name directly into that connection with the schema to use, just like that. The only way this is possible is by actually having this database wrapper on there. Perhaps there's another way to do it, but this is the way that I found pretty effective, as well as what Django tenants, that really good package, ends up using as well. Something very similar to this. It does work a little bit differently, but I like activating these things like this. So now with this connection name, what I can do is I can open up my landing page view right here. So the landing page dashboard view, which gives me both things, the landing page that's logged in and the one that's not. Then I can come in here and do from Django.db. We can import connection, and then I can just print out connection.schema name. And that's it. That's all I really need to do. So I need to make sure I can run the server though. So let's go ahead and do that with Python and manage.py run server. And of course that will give me my server running. And now I should be able to print out what the schema name is if I'm in the local host, and then into cfe.localhost. There we go. Both of those things are working. So now if I go to abc.localhost, here's how now I can start to think of, oh, this actual tenant is incorrect. This one doesn't work correctly, so it's the wrong schema. In other words, the landing page, or really all of the views, I could think of this single thing and say if connection name is public and the subdomain is wrong or something like that. I'm not going to do that just yet, but that's the point, is we would be able to have a different page or a different template rendering based off of that connection name. Now, there's other things that we can do to continue along the line of, showing invalid subdomains basically, but that's not something I'm going to do just yet. The point of this was really to see, hey, can I actually have the schema name in more places than just one and have it be available to me going forward. So the next part of this then is in the activate schema. All I want to do is I want to check that if the schema to use is equal to connection.schema name, I can just return from there. And that way I don't have to reset it, right? So I can print out something like schema activated, return, something along those lines. Now the public one, I could do a public one as well if I want to. In this case, I'm actually not going to. I'm just going to leave it as is. And then we can now refresh in here. And now it should only set that schema name when it needs to. And we also might consider doing something different as well. But as we see, schema activated return, and then it's still that public schema. And then we got CFE in here, same thing. Okay, so that's actually really nice in terms of the connection schema. The real thing that we need to do now, though, is coming back into our middleware, is having a little bit more efficient lookups for our middleware. I need to verify what the actual schema name is for the subdomain. The way I can do this is by using caching. Performing this database lookup, more specifically this one, on every single request is not efficient. So what we want to do is implement Redis as a caching engine for this project, at least for this one single part. Maybe in other places we'll need it as well, so it makes sense to implement it now. Now the package we're going to use for this is Django Redis. This is a great package. I use it all the time in all sorts of projects. So we'll bring it into our production requirements as Django-Redis. Now we also might need to bring in just simply Redis, the Python package for Redis. Not positive if that's required or not, but I end up using it. Looks like it's in here already, redis.py. We can even grab that. We can see what it looks like, but it gives a bunch of different requirements for it. Now we're going to go ahead and run that installation. So let's go in the root of our project and run rav-run install, and we'll go ahead and hit that enter. We should get our production version going, and then we'll install Django Redis locally. So the question is, where do we actually use Redis? Of course, inside of settings.py, what I want to do is I'm going to go ahead and import my Redis URL. So of course you need to have Python decouple installed to grab that. And then I'm actually going to go right underneath the database, and I'm going to add a note here, and we'll just go ahead and say Redis caching. And what we want here is very similar to the database URL stuff. So I'll go ahead and copy this, paste it in here. Now we're going to call this our Redis cache URL or something along those lines. You might end up using something different for other caches or Redis for other things as well, which is definitely up to you. But I'm going to call this just simply my Redis cache URL. So if it is not none, what we do then is we bring in our caches and we set the default cache to, well, basically the configuration from Django Redis, which you can find out directly from there. There's a simple installation process that you can just grab basically this right here, and you would bring it on in just like that. The biggest difference, of course, is the location itself is going to now be the cache URL there, just like that. Okay, great. So now the question is, of course, where do we actually grab a Redis URL? Now, I typically go and reach for Upstash Redis because it's, well, free to do a lot of really good things. So in this case, I'm going to go ahead and create a new database here, and I'm going to call this my SaaS for Enterprise, Redis cache. I also want to set the region. Ideally, it's in the same region as your other database. Now, in this case, I'll call it dev because it's our dev branch, basically. I'll go ahead and say next. We'll use the free one. I'm going to go ahead and create this. And there is our new Redis database in here. And here is going to be the URL we'll use. So I'm going to go ahead and copy this. And we're going to paste it into our .env. And of course, it's going to be our Redis cache URL. And we're going to go ahead and do something like that. Now, one of the things with the Redis cache is we probably need to use the Redis secure. So we can actually take a look at the documentation on Redis cache, and we see that there's a secure version like this. Well, so 2 S's at the end there, and then we want to have /0. So at the very end of this, we just do /0, and that should configure our Redis cache just like that. So we want to actually test this out, test out this assumption here that it is working by jumping back into our middleware. So we'll go into middleware, into the schemas middleware, into this get schema name. And in the short run, I'm going to go ahead and call it the cache directly from here. So we'll do from django.core.cache. We're going to go ahead and import our cache here. And I'm going to go ahead and come down in here. And what we want to do is we want to check the cache itself. So I'm going to go ahead and give a cache key. The schema name is going to be potentially what the cache key is, but we're going to start it with the subdomain. So we'll go ahead and give a cache key, and this cache key, I'm going to go ahead and give something along the lines of, let's say, for instance, schema or subdomain schema. Let's call it that, subdomain schema. And this is going to grab in the subdomain itself. Great, so that's going to be the key. And what we want to do is we want to get the value. So cache and value equals to the cache.get of that key. Okay, so basically if we have that cache value, then we will go ahead, or rather cache value here, we'll go ahead and return that cache value. If we don't, then we'll go ahead and do the lookup here, and this is where we'll then go ahead and set it basically the same way. So we'll do the cache.set. We grab the key itself, we add in the value, which will be our schema name, and then we can add in how long we want it to work for. So like if we wanted a certain duration, let's say for instance 10 minutes or something like that, we can absolutely do it. So I'll go ahead and say the cache TTL, or time to live, is going to be equal to, well, it's really up to you on how you go about doing this, but it's going to be in seconds. So if you did 60 seconds, it would be 60 seconds like that. So I'll go ahead and just start with 60 seconds, and we'll go ahead and bring that in. Okay, great. So now if it's done correctly, everything will be cached in here going forward. So let me run the server again, and let's go ahead and say that in here, we'll go ahead and say that the schema cache hit, and we'll go ahead and grab what that value is. Okay. There we go. So the subdomain, oops, we made a little mistake here. That should be a string substitution subdomain altogether. Great. So now that we've got that, let's go ahead and take a look inside of cfe.localhost. We see that we get that tenant in there. I refresh again. Now it's hitting schema hit. There's the value. Schema activated return. Great. So everything's in a good shape. It's cached, and then also in the actual database wrapper, both things are in there activating and running. Now we can also verify that it actually did store in Redis by going back into Upstash, going into our usage, and then maybe it's not our usage, but rather our data browser. And we can see here's those values in there, and that's the data coming through. Great, so that's looking pretty good. We've got our schema name. Perhaps we want to change this as a string here. I'm actually not sure if that really matters a whole lot in terms of how this ends up working, because it seems like it's getting that cache back for us, and that's all working and looking pretty good as far as the cache hit is concerned. So there we go. That is how we can implement caching. And the only reason to use Redis versus our local database has to do with the fact of speed. Redis itself is far faster. Now, when you actually deploy this in production, let's say, for instance, your production server has the ability to easily provision Redis. Maybe you end up using that one. The reason I end up using Upstash is because it's free and I can do it in the same region or a similar region to what we are doing inside of our database as well, right? So having that ability is great to make sure the speed is there. And then, of course, if I were to deploy this in a production, I would be able to do so really quickly. Now, the other thing about this cache that's important to note is we don't actually have to set the cache on the requests. So we've got this middleware in here that is setting the cache, but we could actually run a service. We could run, let's say, for instance, on GitHub Actions. If we jump into GitHub Actions, I talked about this a lot in the SaaS Foundations course, but if we were to be in GitHub Actions and run various things related to the caching, we can actually set that cache well in advance so that when we need to go ahead and use it, it's already available. And that's one of the other reasons to use something like Redis, where it's managed for us, just like our database, but also that we would be able to update that cache at any time, pretty much anywhere, and then it's really performant elsewhere as well. We're now going to do a multi-tenant user registration. Now, I want to start off with the public Django schema first and sign up a brand new user. Now, for some reason, if your styles don't look like this, then there's something wrong or some sort of bug with the Django all-auth UI package. which is why that we're going to just really quickly come into our templates down here. We're going to make a new folder called allauth. We're going to drag the original account folder in there. We'll just move it on over, and we're going to change this to being layouts, and then we'll get rid of the logout.html button. That should solve some of the issues that you may have with the rendering of this sign up page. The next thing I need to do is customize the allauth sign up. I actually don't want to use email. I'll explain why in just a moment, but let's go ahead and jump into settings.py, scroll down to the Django allauth config. We want to change the auth method to being simply username, and then email required being false. We're going to go ahead and save that, and now let's go ahead and actually try to create a new user. So this is where the allauth UI, for whatever reason, changes here. Not sure why, but let's go ahead and sign up a new user. In this case, I'll just sign up the username of ABC. I'll give it a password, a whatever password. We'll go ahead and hit sign up, and hopefully what that does is log me in as ABC. Great, so far so good, but this is the standard Django public schema. Let's go ahead and try one of our other schemas. So cfe.localhost, for example. Let's go ahead and sign up a user here. This time I'm going to go ahead and just use cfea, and then I'll go ahead and do my username and password, and we'll go ahead and sign up. So what I get here is this programming error. Now, right off the bat, I have a sense that this is something with migrations or a app not being installed correctly or something along those lines. We've seen this almost exact programming error earlier, which we ended up solving. But the idea here is this is going to be the app name, and then this is going to be the model name. So it's actually fairly obvious as to what's going on if you remember back to how we set everything up. It starts with that installed apps, right? So our default apps are all of these. Our enterprise apps, all of those subdomain versions of this Django project, doesn't have customers. Just the standard public schema does. So right off the bat, I already see that it's trying to create something that it just does not have in its schema. And this happens because of, often Django database signals. So inside of the customers model, in customers models.py, if we scroll to the very top, we see these signals. These are database signals. And what do you know? One is when the user signs up. So when the user signs up, it's going to go ahead and send a signal and then attempt to do all of this. This is one of the reasons why we might want to change how we even do email or just registration altogether. Now, one of the things we could consider doing is using the database connection and coming in here and saying something along the lines of if connection.schema name equals to public, then we can run something along these lines. This should probably work. And in fact, we might want to do this in both places down here. And I'll go ahead and tab this one over. So to me, though, this might be where allauth starts to fall apart. And since we're doing SaaS for enterprise, we might need to do something different than allauth, maybe taking a lot of their code and modifying it to fit with all of our stuff. This might work okay. It also might fall apart as well because it's not really the greatest way to check what is actually happening. We actually have the request in here. This might be another option, is using the request subdomain and figuring out whether or not we want to create this. Now, another thing is just to get customers away altogether and not have a signal handling creating the customers themselves. But the thing is, on my public schema, I probably want to make sure that they are customer accounts. But on my tenants, my enterprise schema, we do not know customer accounts, right? Now, this might be different for yours, but in this case, we want to think about this in terms of what we might do with our signals. So that's something to think about as well. Now, one of the things I did notice, as soon as I started using this in this way, I realized there's actually an issue with this, and that is inside of my schemas. If I just assume that this is activated correctly, I might accidentally not activate it when I need to. So I'm actually going to go ahead and get rid of that and make sure that I always am activating the correct schema when it needs to happen. That's something that we definitely want to have happen all the time. So now when I go through this process and try to re-register at that schema, what I get, of course, at that subdomain, I see this user has already existed. A lot of times with database signals, they happen after the instance or the model has been created and it's already in the database, which which of course we can verify by jumping back into Neon, going into our tenant, looking at our different users in there, and there's that CFE-A user. It actually is registered in there. So let's go ahead and actually try it again though with CFE-B, a new user that we're just going to go ahead and create and make sure that there's no errors here. Now when I go through it, it actually does log this user in, and there we go. We now have user registration. It's pretty great. So this is where I'm going to say that in the long run, what you would probably do is you would probably need to create your own auth views, which we definitely talked about before. We talked about this same stuff inside of using the SaaS Foundations course. We did go through all this. That's why the code's in here. This is where you might want to start creating those users. In fact, especially for the enterprise users, you might want to have additional forms in here that you're checking, not using the same exact form to log in or to sign up. You might want to have something that's different in here, in which case would mean that you need to understand how to build out those things custom. Now, one of the big things that I would say is just checking the data that's coming through. Right now, this is not great. This is actually really bad. We want to actually have our own custom form for the enterprise, especially to verify that maybe we want to make sure that they are logging in through their email and only their email, which actually changes things quite a bit on how we set all of this up. Now, the reason I'm not going to go through that is because it's fairly tedious to get to that point, but it is something well worth thinking about when it comes to user registration. But now at this time, we actually do have user registration going. So we can actually log in to our enterprise application as different users, and going into our Neon console, we can actually see this being true. We can look at the actual database and see when a user's logged in. And so now what I want to do is actually just make a slight modification to maybe the page visits and actually store the user instance in there to see it actually working in another way, and also help allude to what you can start building on top of this with a lot of the other standard Django stuff. Jumping into the page visits model inside of the visits app, we're going to go ahead and change this so we can actually track it to a specific user. This, of course, is going to give us an insight into what we need to do for all of our models that might be user correlated, whether it's in our main public Django app or in any of the tenant applications. So the way we're going to do this is from django.conf. We're going to import settings, and then we're going to go ahead and use the user model. So settings and .auth and user model, and then we'll go ahead and bring in a foreign key. So user equals to models.foreign key, and it's going to be the user, and we'll go ahead and say on delete being models.set null, and we'll go ahead and do null equals to true and blank equals to true. So what we should remember always whenever we change our models, we come through and we run python manage.py, and we run python manage.py make migrations, and then python manage.py migrate underscore. Well, let's make sure that we're not skipping the public one. So let's go into our commando management and into our management commands for migrate schema. Let's just make sure that we aren't skipping public. Looks like I still have skip public on here, which I'm going to change to being false. So back to that. Of course, I can make that in as an argument as well, but I want to just make sure that I'm running the correct one with migrate schema. So first it's going to do it on the public. Looks like we've got tenants alter subdomain, which is interesting that changed as well. I don't remember what I did there. It's probably the validations, but overall, here we go. We've got visits on both ones. So the customer apps and the standard Django app is now in there, and it's now working. Great. So with this in mind, let's go ahead and just check that it is working by enriching where we actually create those instances. So in the dashboard views.py, we've got our dashboard view. Clearly it's not here. We're going to go into landing and views.py. Clearly it's here. Okay, great. So what I want to do then is I'm going to go ahead and grab this page visits object here. I'm going to go ahead and bring it on in right there. I'll go ahead and say user equals to none. Now I'll go ahead and say if request.user.is authenticated. Then we'll go ahead and say user equals to request.user. Now in our page visit, we'll go ahead and pass in user equals to user. And then in here, we'll go ahead and say if user is not none. We can still use request.user authenticated as well if we wanted to, but there we go. So now we've got a way to track page views on any given page. Of course, we could do this in a lot of different places, but for right now, I just want to check the login version. Okay, so I log in here. I'm on the main public app with the ABC user. I'm going to refresh a few times on this homepage, and then I'm also going to jump into cfe.localhost to use the tenant user on the CFE_B. So these sessions are separate. They are separate sessions from one another, which is super nice. Now, if I go into the Django admin, what I should be able to see, let's go ahead and log in with the correct super user one. I can log in here, and we should be able to go into our visits. And looks like it's not actually in our admin, so let's just jump into the Neon console, into public, and we'll scroll on down to page visits, and there should be a lot of them in here. Here is that user ID column, and what do you know? There's a user ID associated. Now, if I jump on over into my subtenant, I can scroll on down, and what do you know? There is a user ID as well. Exactly what it is that we are searching for. So the other part of this is, hey, what do you know? This particular model is shared both with the public schema and all of the enterprise apps that we might want to have. So then maybe in our dashboard view, let's go ahead and grab our dashboard view here. I'm going to bring in those page visits. I'm going to go ahead and grab my query set being pagevisit.objects.filter user equaling to request.user. Hey, what do you know? Login required's there. So now I can bring in my page visits, and I'll just go ahead and bring in a page visits count or visit count being qs.count. Just like that. We will now bring it into our template here, and there we go. So now I can just jump into dashboard and main in that template, and let's take a look. Here is some stuff related to it. I'll just go ahead and put an H1 tag and do page visits, whatever we called it, visit count, and there we go. So we'll go ahead and say visits or my visits, something like that, is equal to that visit count. Let's go ahead and log in and take a look. Here we go. That's on our main public site. This is now the admin user of CFE. If we go into our enterprise one, we should be able to refresh. And what do you know? My visits is certainly different than the other user. No surprise there, hopefully, but it is just illustrating the point that, yeah, this is how you're going to associate data to your multi-tenant applications. And of course, if you want them in public, they can still be there. Now, the last real main thing that we need to do is we need to make it so that the tenant portion is more automated. Right now, the tenant portion is not very automated. We've got the tenant model. This is great, but it doesn't actually create and do the schema migrations when the tenant is created itself. That is certainly something I'll want to do. Whenever we create a new tenant or even save it, we want to make sure we're migrating that tenant's schema. The way we're going to do this initially is by calling our migrate schema command. So we've actually already seen this a little bit when we tried to call the command for the public migrate. We're basically going to do that same thing. So I'm going to go ahead and copy this and bring it into models.py for our tenant, and we'll just focus on the call command here. And then I'll scroll down to where the tenant is, and right after the customized save function, we're going to now call command the migrate schema. Now, you might think this is enough because it should run all of our schema migrations from this point, but of course, there's going to be a catch. So let's go ahead and take a look at what that catch is. If we were to jump into our project, feel free to delete any of your tenants if you'd like. I'm going to just go ahead and create a brand new one. This one, it doesn't actually matter what user you give it, just give it some user. It also doesn't matter what subdomain. If we hit save and continue, it seems to be working. If we go back into our terminal here, we can actually see that it looks like the migrations are going through. But we're actually going to run into a little bit of an issue that has to do with this. What's going on here? Well, this has everything to do with the fact that we are running the migrations in the first way of doing it. So you might already see this right here where we can already hopefully think about how we ran the public migrations before, the public schema stuff. We create a specific helper called use public schema. So right off the bat, what I want to do is in this migrate, I want to change this connection right here to use that public schema. So we'll go ahead and do from helpers.db.schemas. We're going to import that use public schema. So now I can use that instead of this main one. So I'm going to go ahead and change this to just simply use public schema. And then I'm going to pass a few things that are basically public schema related, which is calling the migrate command. At this point, I don't actually want to skip this ever, so I'm going to go ahead and just leave that in there. Now, one of the things about the query set here is I actually iterate through it later. So I'm going to go ahead and copy that and change the filter to just being none. So basically, if I have none, it will always be none. And that way this, loop doesn't actually fail here. Now, this didn't actually change anything in terms of the post save command, this command right here. This actually just allowed for the public schema to be a little bit closer to what we want. We can get rid of all of those other commands as well. This definitely refactored it pretty well. But the reason we saw the problem that we saw is because inside of the actual tenant object, when we're looping through, we see that the very last thing that's being activated is going to be the non-public schema. So in other words, I need to create something like use public schema for this section right here. I actually might use it in other places as well. So that means we need to jump back into schemas.py. I'm going to copy this use public schema and paste right above, and we're going to call this use tenant schema. So a little bit different than activating the public one. So we're going to go ahead and say something like this and then pass in the schema name. This is not going to be tenant anymore. It's going to be more like visits.object.all. So I want to come in here and bring in that schema name. Then I want to do something like revert public. This time it's going to be like, hey, we're going to use this schema and whether or not we want to revert it back to the public schema. In this case, I'm going to go ahead and say true because I know inside of this migrate command, I want to revert back to the public schema. Granted, I could probably put this at the end as well, but I want to have some sort of temporary schema user. That's why I'm doing this context manager in the first place. So down here now, I'm going to go ahead and say use or revert public, and then we're going to go ahead and just put in that default schema just like that. Great, so we're already in a good place in terms of using the public schema and the temporary schema. So of course, the next thing that we need to do with this tenant schema is we need to check whether or not it exists, just like we did with activating it, in which case I can just go ahead and copy this right here, and we want to put this inside of that same connection overall. So I'm going to go ahead and come back in here and basically check whether or not it is required, which in our case, we're going to go ahead and say, instead of check if it's required, we're going to go ahead and say create if missing, something along those lines, and we'll default that to being true. So we'll go ahead and say if create is missing and not, as in it does not exist for that schema name, then we want to go ahead and run a cursor command on whether or not we need to create it. What is that cursor command? Well, going back into Migrate, we did it right here. This is it right there. So we can go and bring that one in, and I'll just go ahead and paste it in right here. I probably don't need schema to use anywhere. I probably just need schema name. But if I break this down, I should be able to see that this is now going to be called inside of that same connection in there. So I'm going to go ahead and get rid of this schema to use here just because we want to use just this standard schema name. Great, so now let's just reiterate. We've got our schema that we're going to pass through here, which is going to attempt to connect it or create it. If it's not there, then it's going to run through the rest of the process. Now the DB statement here, I still like that statement. I think it's nice. But the thing is, I'm going to go ahead and just hard code it in there so that if at any time I need to do anything with the schemas, I can see everything that's going on right in there without needing to reference another file for these specific statements. And I'll just use that F string just like that. Great. So with this in mind now, let's go ahead and use this tenant schema now. Go back into our migrate schema and we will bring this in. And I'm now going to go ahead and change this with statement to use tenant schema of the schema name. We're going to go ahead and create if missing being true and then revert public being true as well. We could maybe even call that revert default, but I'm going to leave it as revert public. So now we've got some of these commands in here that I no longer need. So I can go ahead and get rid of all of those commands, but now just tab in everything else. So I want to tab in basically everything else with the exception of the last write out message here. And so if I pass this back, what I see is now it's going to loop through each tenant. It's going to activate that tenant temporarily. Then at the end of that tenant being activated, it's going to revert back to public, which is what's going to happen with every single one. So now with this in mind, I'm going to go back into my models and I've got this migrate schema here. We're looking hopefully a little bit better. Let me go back into the add function here. What we probably will see is if we go in here, it's not actually stored in there. And if we go into our database, it might actually be in that tenant object itself, but it's not. I'm actually not sure why it was removed. I think maybe because it maybe tried to move it into a database schema that just simply doesn't exist. If you know the answer, please let me know. But overall, now we can actually give this a shot. So hopefully with this new use tenant schema thing here, we should be able to manage the schema right inside here. So I'm going to go ahead and go into tenants. Let's go ahead and add a new one. And let's go ahead and do that ABC123 again, save and continue. Now the migration is going to happen in line and it's going to happen for every single tenant. Of course, if there are other tenants that need migrations, it would go ahead and do that. But what we'll end up seeing here is once those migrations are done, then we've got the tenant scanning. All those errors are now gone. And so I should be able to jump into my Neon database and see how now I have 3 total tenants, 1 public, and then 2 of the other ones, which this one is 9F37. So we got 9F37, and there we go. So there's our new one with no public visits and no users. Fantastic. Okay, so we still have a big problem, and that is that we actually are iterating through all of the tenant objects themselves. And more importantly, I actually don't love calling the command line commands directly inside of a model like this. So we want to change that as well. Let's take a look. Now, very rarely do I actually build out a Django management command in this way. Normally, I only do it this way if I'm testing things out and I need to run the command really, really often. This migrate schema is a good example of that. We wanted to run it often before we actually made it a little bit more effective for our use case. So I'm going to go ahead and decouple this migrate schema command so it's actually stored somewhere else. And the way I'm going to store it is inside of the tenants app called tasks.py. Now, those of you who know Celery, this is actually going towards turning this into a background worker process as well, which is why I'm doing this. So the idea here then is I'm going to copy this entire command itself. We're going to paste it in here, and I'm going to get rid of the command class and just leave the handle class for the moment. And then I'm going to go ahead and get rid of some of the imports that I might have in here that I no longer need. Okay, great. So this handle command is going to be something like our migrate tenant schemas, and we'll call it schemas tasks or task, and we'll leave something like this in. Okay, so these arguments that are coming through here, we probably don't need. Self itself is about print statements. If I scroll down a little bit here, we see that this is a print statement. Basically, I'm just going to change it into a print statement for now, just to make it a little bit easier on myself when running this. Now, this std out, right, that one I can leave as is. Everything else should be good. Okay, so now we've got this migrate tenant schemas task. I'm going to get rid of self in there, and I'm going to go ahead and import this now into my migrate schema. Now I'll go ahead and leave the comment of the shared task off because I'm not setting up Celery in this one. But let's go ahead and use this migrate schema now into the command itself. So now what we'll do is just do from the tenants and dot tasks, or we'll do from tenants import tasks, and then we'll go ahead and bring in that task here. And this is going to be the main command, so I'll go ahead and just bring in task dot and then migrate schema tasks. If I was using Celery, I could do something like delay, but I'm not using Celery, so I will not do delay. I'll just call it directly, and then I'll scroll all the way down to where that print statement is or the std out statement is, just like this. And then I'll go ahead and copy this first, and then we'll go ahead and just write out migrations starting or something like that. Starting migrations. Great. So we can save that, and let's go ahead and give it a run, and we'll just go ahead and jump into our SRC here, Python manage.py migrate schema, hit enter. This should run everything like it has. There's the starting migration that's spelled incorrectly, but it still is there. Great. So with this in mind, I can now go back into my tasks and really start to decouple this thing. Now, first and foremost, the migrate schemas task, do we actually want the public schemas on here? This is actually where I'd say, yes, you probably do want it so that we can actually get the tenant filter itself. although it's not fully necessary. So in other words, we can come in here and do something like migrate public schema and call that a task as well. And then just run this right here and this right here. We'll cut that out and we'll just go ahead and paste that in. I think it's redundant. I don't necessarily think we need to do both of those things. But of course, I kind of feel like if I'm going to migrate all of the tenants, I might as well also migrate the public schema. So it's going to be up to you on how you go about doing that. I'm actually going to put that in both places just to make sure that everything's migrated correctly. But of course, we could use this or not. I'm not going to use it, but it is nice that it does exist in there. And again, if we ever needed to turn it into a Celery task, we would. Generally speaking, though, the actual whole migration, the public migration, needs to happen before it's deployed. Django will have some issues with you if you do not do the public migration prior to deploying it, which is why if you look in the Docker file, we do have migrate in here just like that. That's a big part of the reason. You need to make sure that's done. With that out of the way, I'm going to go back into my migrate schemas task. And now what I want to do is I actually want to get rid of this for loop as being a for loop like this and actually have a single migrate tenant. So I'm going to go ahead and now do migrate tenant task. I could say tenant schema, but I just want to make it a little bit like separated from the other one. So I'll go ahead and bring in, we could use the schema name. I'm actually going to use the tenant ID here, and we'll go ahead and use an str. This, once again, I'll go ahead and grab the tenant. Now I'm going to go ahead and do a try block and say the instance equals to tenant.objects.get ID equals to that tenant ID. And then if there's anything other than that one, we will run the exception. And I'll just go ahead and print out, something like the tenant with the tenant ID failed. And we'll just go ahead and put that error right there. And then we'll just return it. Okay, so this is now the tenant task I want to use, which is basically going to be what we do down here. And once again, if we were using Celery, we could just go ahead and do delay and put it as an asynchronous worker as well. So what I want to do, though, is before I go any further here, is I'm actually going to filter this, get rid of this filter. I'm going to go ahead and do all of the schema migrations now. And then I'm going to go ahead and get the values list of the IDs, and I'll just go ahead and say flat being true. This is a little bit more efficient than grabbing the whole thing. So this is going to just be our tenant ID now. And now we can go ahead and bring that in like that. Great. So back up here then, I'm going to go ahead and now grab the schema name. And we will bring it down like this. This is now going to be the instance object. There we go. What you might also think about is, hey, what if I just grabbed the schema names instead of the ID, and then I could just jump into the schema migrations itself? Certainly an option. The reason I have this is because I want to make sure that that tenant ID exists when this task is running, regardless of whether or not the schema name is valid. Okay, so with this in mind now, the next step is going to be grabbing the entire executor. So I'm going to go ahead and run all of that, and we'll go ahead and bring this on up here, paste it in, and we might need to tab some things back potentially. Let's go ahead and tab that one back. Now we should be in good shape. So I'm going to go ahead and just run that. And that's going to be it. So now we've got our migrate schema task here. I'm going to go ahead and get rid of that. And that's it. So now we've got the standard one that does all of them and grabs that values list. And then we now have the individual one, so we can only run the individual task as needed. This is going to be great for our models. So going back into our models, we can now do from utils as well as from tasks. And then we're going to go ahead and change this from call command to just simply tasks dot. This is going to be migrate tenant task. And then we're going to pass in self.id. What do you know? Once again, we could change that into being delay if we want to. But once again, I do want this to run every single time this is saved. So if we make any changes to the tenants, this should run. Great. So let's go ahead and verify a couple things. First off, let's make sure migrate schema is still working. So I should be able to run this, and it should be able to run everything as we saw with no errors. Everything's looking good. Now we want to jump into the Django admin. Let's go ahead and create a new tenant here and say just another one. Doesn't really matter what we call it. And there we go. This should be a dash probably. There we go. We'll hit save and continue. And this should, in theory, run that schema migration specifically for that one and just that one. And there it goes. It's just doing it for that one. It should be significantly faster than doing all of them. And of course, it's a one-off thing. So that's going to work better for all of them. And of course, if we actually were to run the migrations again, I shouldn't have any issues whatsoever, which I think is a key part of this as well. But now that we've got that, we are in a really good place to add new tenants at will. It's quite literally exactly what we're looking for in terms of those schema migrations. And then of course, the actual subdomains themselves, if we come in, let's go and grab one of them, another one, we can come in here on localhost, another one, and there we go. So now we're on this home page. Everything's looking okay. Let me just jump into one of them. What's the actual ID here? We got D577. I'm going to jump in here and we'll look at D577 page visits. What do you know? There are those page visits. We are starting to get that multi-tenant app really cooking. Now, one of the things that's really cool about this as well is this new use tenant schema. I want to actually show you why this is so cool in just a moment. Now we're going to create the tenant list and detail view. This is going to be coming from the Profiles app in that view itself. And this only has list and detail as well. So I'm going to go ahead and copy that. And we're going to go ahead and paste it into our tenant views. The very first thing is going to be our tenant list view. Let's go ahead and build this one out. It's going to be fairly straightforward. First off, we can get rid of some of the imports that are on here. And I'm going to go ahead and bring in from the tenants and .models. We'll go ahead and import tenant. We could also just do from .models. That also works. I'm going to go ahead and now filter this through. And what I want to filter it down to is the owner or the user, which is going to be request.user. Now, granted, we could also think of this in terms of if the owner itself had permission to do things, or the requested user had permissions to manage the actual tenant model itself, which is not something we're going to do at this time. Next up, we're going to do our tenant detail view. This time, instead of username, it's going to be our primary key or our ID, which I'm just going to go ahead and say PK, and we'll leave that in as a required argument. So once again, it's going to be very similar to this, but it's going to be a little bit different as well. So we'll go ahead and get rid of some of these things in here. The user is going to be just referred to as the owner. And we're going to go ahead and do owner and owner, and then the tenant in there as well. This is going to be now just simply instance, which we'll leave it as, and there we go. And then we'll go ahead and get rid of is me and the owner stuff right there. Next up, we're going to go ahead and change the template names to tenants, like that. No big deal. Hopefully all of that is fast review for you. urls.py now, we're going to go ahead and bring in from Django.urls import path. And then our URL patterns are going to be equal to an empty list here. This, I believe we have in profiles as well. So we can always just copy that also and just go ahead and paste that in just like that. The actual ID here is going to be PK, and the views are going to be the tenant list view and then the tenant detail view, of course. Next up, we're going to go ahead and grab the templates themselves. So let's go ahead and take a look inside of templates. I'm going to copy profiles and we're going to paste that in and call it tenants. And then we will go ahead and take a look at the list view. The list view is going to be tenants now, and we've got tenants. We don't need the permissions in here, so I'll go ahead and get rid of those permissions there, and I'll just go ahead and have the list come through. So hopefully that is about correct. Next up, we're going to go ahead and change this from profiles to simply tenants, and then we'll go ahead and do instance.pk, and then instance dot maybe like subdomain. There we go. So hopefully this gives us what we need on the list view. The detail view, once again, we'll go ahead and do tenant. Instance.subdomain is what we'll put in here. Obviously, we could put more things in here if we wanted to. And then that's pretty much all I'm going to put for now for the detail view. Great. So with this in mind, let's go ahead and bring it into our urls.py. So in CFE home, URLs, we can scroll on down to where the profiles are. And I'm going to go ahead and copy and paste that and just do tenants and then our tenant URLs. There we go. So if we save that, we should have everything running again. I want to jump into the public Django project, just at localhost there. And I'm going to jump into tenants. And there we go. So we've got different tenants in here. And these 3 tenants should technically be the same owner. And so I just want to verify that within the admin. The way I'm going to do that is by jumping into the tenants admin. And we'll go ahead and grab a list display. We'll go ahead and do our subdomain, the owner, and then we'll also go ahead and add in the schema name as well. We can refresh in here and we should now see those things. So yeah, there's the owner. I'm going to go ahead and change one of the owners just so we can see that happen. What do you know? That's also a way we might be able to transfer these tenants as well. It's going to be that easy. Okay, great. So now if I click on one of these tenants, I should be able to go to that single tenant. But what we get is this get it returned to. So let's go ahead and see why. I think I know. And that has everything to do with the fact that it tried to do get or 404 with the owner and not using the primary key. Let's use the primary key now, refresh, and there is our CFE tenant. It's important to remember that our manager users, those enterprise manager users, are going to use the core Django project, the public Django project in that public schema. So when they go to use that, if they want to manage their users, the enterprise users, the users that are stored in that tenant schema, they still will have to log into public, which means that this actual detail view needs to be on the public schema all of the time, which means that we actually need to update our urls.py, and the way we're going to do that is with Django-hosts. We'll still do that very soon, but before we even do that, we can still test out some of the assumptions on how you could go about building this out. So the first thing I want to do is actually take a look at the users. This same concept could be with any of the models that are installed on the tenant schemas themselves. But users were there by default for obvious reasons. But the idea here now is what we want to do is we want to go ahead and do users equals to user.objects.none. And the idea here is these are not actual users. These are more like our tenant users, or what I was calling before in the definitions as our enterprise users. So I'll stick with the enterprise users here, and we will go ahead and pass that in as context to the detail view. And so in that detail view, then I can actually loop through and say for user in enterprise users, and then we'll go ahead and do an in for here. And all I want to see for this is maybe a list element, and I want to take a look at the user data. The user data is going to be straightforward. It's going to be user.id, and then maybe the user.username. And that's it. That's what we'll show for now. And of course, at this point, it's going to be none, right? So user.objects.none. Let's just quickly change it to simply .all and take a look at this detail view. If I were to jump into that detail view, I see there's 2 users in here. But these users, of course, are only for the main site, the single tenant public Django application, public schema, all that. So we want to change this a little bit, and hopefully you already have a sense as to how we might change it. That is going to be using that context manager that we created just a little bit ago. In helpers.db.schemas, we're going to go ahead and import the use tenant schema here. This is where this function comes into handy quite a bit, is because now what we can do is inside of this detail view, we can go ahead and say with use tenant schema, we pass in the name, which is of course instance.schema name, create if missing. I'll go ahead and say true. This is the tenant detail. If for some reason the tenant does not have a schema available, we want to make sure that it's created. Then I also want to revert back to the public schema when it's all said and done. And so now I'm going to go ahead and do this, and I'll just update my enterprise users just like that. The first level is just going to be simply none. So in other words, it's going to go ahead and say none by default, but they're still user query sets. We're going to go ahead and save this, and let's take a look. If I refresh in here, the same thing happens. So what's going on here? Well, the way Django actually evaluates query sets is it doesn't happen until it's looped through. This is also true on a template. So if we take a look at our template, this detail view right here, this is going to loop through that query set. This is when it's actually executed, is right in here, which actually happens after we did the context, and then we fed that context, or the schema, the context manager, after we formulated the query set. It was executed later. And of course, this actually reverted to public. So yeah, it's not actually doing it inside of the database. What if we change that to being false? Or I should say it's not doing it inside of the correct schema on that database. If I change it to being false and then refresh, now I actually get the correct data. So it didn't go back to public. But of course, this creates a whole nother issue for me when it comes to using this same page all over again. I might have some errors in here and all that. So all I want to do is change this back to revert public being true, because I'm going to go ahead and change this a little bit. The thing I'm going to change about it is how I actually unpack this data. It's no longer going to happen in the template, but rather it's going to happen right in line here. So I'm going to change the enterprise users to an empty list. And then this one, I'll just do a list comprehension, and we'll go ahead and do something like the username. It's going to be x.username, and then comma, and then we'll go ahead and do the ID as the next one, and x.id, and then for x in that list right there. And so that will actually execute it for me, in which case I should see the correct one coming through in here. Let's go ahead and make sure our server is still running. I think I might have had an issue with the for loop. Let me just try that again. And now it's actually rendering out correctly. Now, another thing we might consider doing also is just calling list on that element. We run that, and that also should give us that data back, and it should work just as we've seen before. So this use tenant schema, this context manager, is going to be very effective for us if we are evaluating that data inside of the view. Now, one of the things to think about here is, where do we actually cache it? So how can we cache this? This is where we would probably want to have specific tenant caching. That way there is no potential overlap for the actual enterprise data. This is a little bit different, or actually I should say a lot different than the caching we already have. This caching right here just helps us get the schema name based off of the subdomain. It does not actually extract any of the data from that schema. Whereas our view, on the other hand, will. So we want to have a, like a per tenant caching system set up too, which is well outside the scope of this one. Now, the point of this, though, is once you actually get into the caching, this will be really, really critical when you start having a lot of data. Where we're at right now, we're not going to need caching for a good amount of time for our enterprise users, and also the enterprise subdomain when we actually use all that with Django-hosts as well. But this actually gives us an insight as to what we can go from here. So actually creating new users in here as well. If I use this same exact endpoint, I will be able to create new users and insert them into the tenant schema and that tenant database based off of what might be installed in that tenant database itself. So there's definitely a lot of things that can go wrong in here. Like, for example, if you wanted to try to do tenant.objects.all inside of this schema. Let's go ahead and try it and just do a list here, and we'll see what happens with that one. If I refresh in here now, I should get this programming error. That of course exists because the tenant model itself does not exist inside of the tenant schema, which of course you could do, but then you're getting into a whole realm of tenants managing tenants, which is well outside the scope of something I recommend doing at this point, or maybe even ever. Especially with a single Django project like this. But now we've got the way to do multi-tenant analysis, and we now can actually edit and make some changes to any given tenant, which is super cool. This also means that with what we just did, we can add new users in a way that is, I think, very straightforward. We just add this in, and then we can save a new user. So let's take a look at how we do that. Now we're going to go ahead and register an enterprise-only user inside of any given tenant on our public Django schema. Now, of course, the way we're going to do this is very similar to what we did with the detail view, but of course, it's going to be using an actual Django form. So let's copy the detail view, and we're going to do the create user view or something like that. We're going to get rid of the enterprise users in here. We don't need that, and I'll just go ahead and do pass after this tenant schema part, and we'll go ahead and run something like that, and I'll call this new user as the HTML. So what I need to do, of course, is bring in a form itself. So the bringing the form part in is going to be from Django allauth. So we'll do from allauth.account.forms. We're going to import the signup form. Now, a big part of the reason I'm using the signup form from allauth is it already has a bunch of the validation built in. It has all of the things that I might want for a signup form. There's no other reason than just that. The way the forms work will be the same regardless of where you're using them, which we can test out as well. But the idea here is we want to bring in that sign up form. We want to initialize it, and we'll go ahead and do that with this right here. Now we can also initialize the same thing as request.post or none. Realistically, we just need to have some sort of default value here and then reset it with the tenant schema itself. Then we're going to do what you would normally do. So we would check form.isValid, and then you would do something like form.save, and then we would want to return back somewhere. So I'm going to return back a redirect, and we'll just go ahead and redirect back to the main page. So I'll go ahead and do instance.pk here, the main page being the main tenant page, and then we'll go ahead and just do the tenants of that primary key. And that should give us that redirect. So I'm going to go ahead and import that as well. There we go. Okay, so hopefully this ends up working. So let's give it a shot. Inside of our templates, we will go ahead and bring in that create. I'm just going to copy the detail and do new user.html, which is, I think, what we called it. And sure enough, it is. So then instead of looping through the enterprise users, we're going to go ahead and bring in a form here, which I'm just going to go ahead and copy and paste. This is very straightforward Django. It's not really that complicated, hopefully. But the idea here is now we've got this form. So let's go into creating a new user, which of course I need to create the URL for it. So let's go ahead and do that now. I'm going to go ahead and copy the detail view once again, and then just new user. And we'll go ahead and do our tenant create user view. And then we'll refresh in here. This should give me a template, but it doesn't seem like it is. Let's go ahead and see why. Let's make sure everything's all saved up. Looks like it is. And there we go. Okay, so now I've got an actual form to fill out. So I'll go ahead and say new user ABC, and then I'll go ahead and put a whatever password in here. You can absolutely make the passwords much better and have validation built in. That's something cool about AllAuth. I get this base form sign up missing one positional argument. So my assumption here is that Django AllAuth on the save method, you need to bring in the request here. So I'm just going to go ahead and bring in that request. We'll refresh in here. We'll run it again. This time it actually does create that new user inside of that tenant, which we could test out by going into other tenants, right? So if we go into another tenant, is that user in there? No. If we go into our Django admin, is that user in there? No. And then of course, what we could also do is take a new user. So let's go ahead and jump back into our tenants here. And I'll go ahead into our subdomain of CFE. Let's go ahead and create a new user once again. And this time I'll do, let's say for instance, like Jon Snow, just like that. And then we'll give a password and a password, login, and or create that user. Great, looking good. Let's go into the local host now, and let's go ahead and log in here. First off, I got to log out of this old user here, and then I'll go ahead and log in now as this newly created user and go ahead and attempt to log in. And sure enough, there we go. I can actually log in as this enterprise user. Granted, we could do all of the other things we might need to with this, that is updating the user, deleting the user, all of the CRUD stuff can be done with this same sort of setup, which I think is fantastic. Very, very straightforward to do. A big part of the reason we didn't actually have to unpack anything this time is because the form itself is going to actually do the database calls directly. It's not like doing querying like what we saw up here. So if we wanted to look at the detail view of a user, for example, we would use this same thing, but then we would actually have to have a detail, which I can show you really quickly. It's not actually that hard to do. So if we come down here and just say something like tenant user detail view, this is going to be our tenant PK now. So we'll go ahead and call it tenant PK, and then we'll go ahead and do our user PK and just change things slightly, not that big of a deal. Then down here, we would come in and grab that user object. So I'll go ahead and say the user instance is none. Then I'll come down in here and say instance equals to user.objects.get, and the user ID or the PK equals to the user ID or the user PK, either one. And then we can actually just return back. Let's do an HTTP response here with that ID. I'll just go ahead and do user instance.id and then dash user instance.username, something like that. Let's go ahead and bring that HTTP response in, and we're going to go ahead and do from Django.http import HTTP response. There we go. So now we've got that user detail view now. This context we probably don't need. I can just put in an empty response if for some reason the use tenant schema context manager is not working, but it definitely should. Okay, so now that we've got this, let's go ahead and bring it into our URLs. I'll copy this now, paste it below, and we'll go ahead and change this a little bit to our user detail view, which takes in the tenant PK now, which is going to be this string. I'll go ahead and do users, and then I'll go grab this again, and this should be an ID, but we'll just do the string as well and just see if that ends up working for us. Now that we've got that, let's go ahead and grab the fourth user here. So we'll go ahead and do users and 4. Oops, let's go ahead and do users/4. And there we go. That's showing our detail view in there. So granted, now we can see how we might build out all of the CRUD stuff related to this tenant schema. Now that we can create things and view things, it's very, very logical and I think very easy from here to build out all of the management you might need for any given tenant. It's pretty good. Now we need a way to handle valid and invalid subdomains. So if anyone goes to something like not real as a subdomain, this should give me a specific page that says, hey, this is not a valid subdomain. Versus something like CFE, which we do have stored as one of our tenants and one of our subdomains. So what we are going to do here is modify the request so it actually does have whether or not this tenant or this subdomain is valid. That's kind of the point here. Now, on one hand, we can absolutely use something like Django-hosts and actually modify the subdomains we want to have valid, but this is a hard-coded process and not something I want to do. I absolutely want to use Django-hosts, but not to hard-code the valid and invalid subdomains. That sort of validation will be stored inside of our public schema database. So the idea here then is to jump into our views here. I'm going to go into the landing page view, and all I want to do here is I want to iterate through for key value in request._dict, then we'll go ahead and copy what that value is, and then we'll go into the items, and then we'll print the key value pairs here, and I'm just going to go ahead and tab things out a little bit, and we'll just use the string of value and just use up to a certain amount, right? So I really just want to see what that request looks like, as we'll see by just refreshing any of these pages. And so as soon as we see that request, we see all of these different values that the request has. You might be already very familiar with this, like requested.user. Right now it's an anonymous user. So what we actually want to do is we want to update our middleware to create something very similar to this. So going back into the middleware for the schemas, the schema tenant middleware, all I'm going to do here is inside of this call here, I'm going to go ahead and say request.tenant active being true, right? So we're just going to leave that in so we can see it inside of our request. If I now refresh in here, what I should see is that value in here somewhere. Let's go ahead and take a look at our tenant active. There's that value right there. So naturally, this is stuck at true, which is not actually the case, always. Sometimes it will be, sometimes it will not be. So what we want to do is, of course, enrich this itself. And basically what I want to do then is inside of a view of some kind, I can say something along the lines, if not request.tenant active, then I can return back some sort of different response. I'm not going to actually build out these responses here. I think at this point you should probably know enough about Django to be able to do this. But the idea then is coming back and saying something like invalid subdomain, right? Like that. Okay. So now if I were to change this to false, all of my subdomains are going to be invalid. So if I come in here, literally every page will now be invalid. So naturally, we need to get this right if we're going to be handling it. Now, on one hand, we could also have this return response inside of the middleware itself. There are many different options on how you might want to think about that specifically. So you could absolutely run this HTTP request in here if it is false, right? So we could say something like if tenant active equals to false, then you can return back that same HTTP response in there. This absolutely might be something you want to do in the future. But for now, we're just going to go ahead and implement this tenant active part. And of course, this is going to be coming from when we actually get this schema name, which will hit our database or the cache if that's available. So what I want to do here then is we'll go ahead and now say the tenant active being a new field that comes back from this lookup. So to implement that, we just go into get schema name. The public one is always going to be true, so we'll just leave that as is. Now, of course, we want to actually get the caching going on. So we need to update how we actually use the cache. So first off, I'm going to do the cache subdomain key being a little bit different. So it's going to be cache subdomain like that, and then subdomain like this. And now we'll go ahead and use those two things. Now, of course, I actually don't want this print statement any longer, so I'll get rid of that. The next part of this cache stuff is just to duplicate this, and now it's going to be subdomain valid key, and we just do subdomain valid schema, something like that, with the same sort of values here, and then we'll go ahead and do valid key, and now we'll go ahead and say if it's both of those things, great, which means that I can just go ahead and return true or whatever that value ends up being, which of course will be true based off of this if statement. Okay, great. So now that I've got these things, I want to actually come down and start setting these values. So the cache key, the first cache key is going to be that subdomain key. So I'll go ahead and paste that here. The actual keys themselves are important, of course. So now what we want to do is just this actual block right here. Now I'll go ahead and say the tenant active being equal to true. This, of course, could be a value that's in the actual object itself, right? So that would be a future thing that you might want to improve. Otherwise, I'm actually going to go ahead and say tenant active being false. So all across the board, it's either going to be true or false. So that all that means is now we need to set that value, and this is going to be now our subdomain active key or valid key, and then we set the value itself. This is not a string value. This is now a Boolean value, and there we go. So we can use that same TTL, and now we've got the schema name coming through and whether or not it is active. So if we go to CFE localhost, we're getting too many values to unpack, so it looks like we have a little bit of a problem with our return statement, and that has to do with this down here. So we're going to go ahead and make sure that we return back 2 values all across the board. Now if I refresh in here, I get this active value, not real, I get inactive. So both of these are now working as we need. And of course, the inactive one should work everywhere. So there's something else that we will need to update with this. But again, this is where if it is inactive, we could come in here and change the response. So we can do from Django.http, import HTTP response, and then we can actually return back, if, let's say something like this, if not tenant active, then we will just return back that response, not active, right? Something along those lines. And now every single page in there would be adjusted accordingly, which is nice. So again, you can use either one. Now we got some issues here with our actual subdomain tenants that we still need to work out. This process I'm actually not going to do. The reason for it is because there's a lot of different ways on how you might want to approach whether or not a tenant is active. This is just one of them, and now it's enriched on the request. So every single request we could do that. Now we could also make it even more robust. If we were going to make it even more robust, the idea being request.tenant then being based off of some sort of tenant model itself, and then grabbing what that would end up being, right? So it'd be something along those lines, very similar to that. But this is quite a bit more complicated to implement, but it'd be very similar to doing the request itself or the request.user. Now, part of the reason I'm actually not handling the inactive tenants on the middleware has to do with the fact that I intend to change all of my requests to be based off of not this right here, but rather changing our URLs, our default URLs, so that we have our public URLs, and then we also have our enterprise URLs. And the only way we really want to do that is with Django-hosts. Now we want to have specific URLs and views for all of our enterprise customers. All of those subdomains need to be mapped a very specific way. So the way we're going to do this is with something called Django-hosts. Django-hosts allow you to map subdomains to specific URLs. It's actually very similar to something we've already seen before, which is inside of Django's URL configuration. This include statement is very similar to what we're doing right now. But instead of it being a URL path, it's going to be a subdomain with those URLs. So you can kind of think of this same sort of thing, but now with the subdomains themselves. Now, the way we're going to do this is we're first off going to start off by creating an app itself. We want to actually have the foundation for where those URLs are going to live. So let's go ahead and jump into our Django project. We're going to go ahead and do python manage.py, start app and enterprises. And then we'll go ahead and go into enterprises and we'll go ahead and create urls.py. Now for this, I'm going to actually just go ahead and copy a few URLs that already exist inside of tenants. I'm going to go ahead and bring this one in, and then inside of my CFE home, I'm going to go ahead and grab the original homepage view that we had before, and I'm going to bring this into my enterprises as well. Great. So with this in mind, I'm going to go ahead and update my imports a little bit, and we'll go home view, and we'll leave it just like that. Then inside of views.py, all I really want to do is return back an HTTP response. So we'll do from Django.http, import HTTP response here, and this response, all I really want to do is return back like maybe something like your subdomain is, and then request.tenant active, something like that. I don't need the request user in there just yet. I could definitely leave it, but there we go. So these are the URLs that all subdomains I want to use. Now, I might want other ones in here as well, something like our login, so auth URLs right here. So I could bring that in as well. So let me just close these out here, and we'll bring this in. Naturally, I need to bring in the include tab. So you can start to see that this can expand to being subdomain URLs. This is like our enterprises URL conf. So we can actually see this inside of settings.py. If we were to scroll down to our root Django projects URL configuration, that's this right here. If I duplicate that to be now my enterprises URL configuration, it's now inside of enterprises.urls. Okay, so of course I now need to use both of these things. Now, if I were to change, let's say for instance, I wanted to just see what it would look like if I had the other URLs as my primary URLs, the enterprises URLs. If I were to do that, I should see some errors most likely. So I go ahead and run the server, and I'm going to jump into my homepage here, and I should see, oh, subdomain is true, that part's working, that's kind of nice. And then this one is, well, here's the error. So if I go to any of my tenant applications now, it's now giving me page not found. That's because I changed all of the URLs to handle through enterprises.urls. Of course, I don't want to change all of the URLs. I just want the subdomain. So we'll go ahead and change that one now. And of course, the way we do this is with Django-hosts. Django-hosts itself can be mapped to specific subdomains, or, as I mentioned before, you can have wildcard subdomains. But there's some caveats that we need to be aware of. So let's go ahead and implement it first, and then we'll talk about those caveats. So to install it, we're going to go ahead and bring it into our requirements production at the very bottom. We'll save that in, and then we'll go ahead and go to the root of our project here. And I'll just run rav run install to make sure that everything's compiled and installed. So while that's working, I'm going to go ahead and do the next step inside of my project, which is going into installed apps, which of course it says all of the steps we need to do right here, which I'm now going to do inside of my third-party apps. I'm going to go ahead and bring in Django-hosts here. Next up, I'm going to go ahead and bring in the middleware as it says. The first one is going to be our host middleware, which goes at the very top of this. Now, I mentioned before that the schema tenant middleware, we put it specifically after the security middleware. Django-hosts is saying you can put it before. I haven't seen any sort of security issues with this whatsoever. So I'm going to go ahead and go off of their documentation until something changes. I could imagine it changing where the security middleware comes first, but according to their documentation, all of this is fine. So I'm going to stick with that to make sure that it's all working as intended. Okay, so now I've done the first three steps. Then we need to create a module called hosts.py. So let's go ahead and create host.py in here. And we'll go ahead and copy their default usage here. I'm just going to go ahead and grab this and paste it in. We'll come back to this in a moment because we need to go back into settings and we need to do our root and this is going to be our root hosts configuration. And this is very similar to the root URLs configuration. And so we do cfe home.hosts, or of course, wherever your hosts.py file is, which of course you could always put it in enterprises as well. But to me, it makes a lot more sense to put it next to the root URL itself. There we go. So now we have some configuration going through, but is it correct? Is it all good? Well, first off, let's jump into host.py, and what we see here is our root URL configuration. This is our default. This makes sense to me. Next up, what we got is our, wildcard. This one is going to be like catch all of subdomains, almost. So what I want to do, of course, is grab the enterprises URLs configuration, because this is going to be our catch-all. I'll come down here and say settings dot enterprises URL configuration, and then I'll go ahead and add in enterprises as the host name. So the first one is the www. That's the root host name, or the default host name, which we also need to bring in as it says on step 6. So the default host is going to be www. Great. So far so good. We've got a few different configurations on here. Now, if we check our Django project, hopefully everything's running correctly. If it's not, just go ahead and restart it. And now we're going to go ahead and jump into our main project here. So on our homepage, it doesn't actually matter where we do it, on our custom domain that I had before, or just simply on localhost. Hey, what do you know? There's a problem here. It says your subdomain is true. It's not actually giving us the correct URLs. It's giving us the enterprise URLs. This, of course, has everything to do with hosts themselves. This right now is only configured to www. It's not configured to a blank subdomain, as in no subdomain. Now, if I put in an empty string here, what ends up happening? Let's go ahead and take a look. If I put empty here and refresh, it still doesn't seem to be working. Let's go ahead and make sure the server is working. We can't have duplicate host names in here, but let's go ahead and bring it in. It's still not working. So this actually works a little bit different than the URL paths that you might be used to. You can actually just bring in localhost here, or the actual name that you're going to give it. So I'm going to go ahead and say something like localhost, and then we'll go ahead and run this in here. Now it actually renders it out correctly. If we go to dsalsa without www, so that like sort of naked subdomain, we still get the other one. So if our custom subdomain's in here as well, we would want to put that in here also. So dsalsa, and then you would just do custom, subdomain in here as the host, or custom domain rather, and that's it. So, and then we could also just put a caret here because it's a regular expression. We can just say if it starts with that subdomain, then it'll end up working, and we just come in and run that server all over again, and now we've got the subdomains working correctly for the root host. Also for our enterprise subdomains, these are also working to a degree. Now, we might want to test something out, which I will in just a moment, but one thing you will notice is the not-real subdomain is not working. So the reason for this is because this regular expression right here doesn't actually capture all kinds of subdomains. So I have a regular expression that you can use and you can just grab, and this right here should capture that. Now these will go in order, right? So if you actually have a different custom domain than I have here, you can put that in there and make sure that it's above your enterprises one as well. So that would be true for other, subdomains that you may or may not want to support. So say for instance, like, invalid, you could have the root URL configuration, or you can have a whole nother one for invalid, right? But as soon as you actually add in this subdomain here, let's go ahead and say invalid as a name. We can go ahead and run that again. And now we should get all of our subdomains. So not real is now working, CFE is working, and then also invalid in here is working as well. Great. So that's giving me a whole nother set of things. Okay, so we're not quite done with Django-hosts though. I want to actually do one more thing with my enterprise URLs, and that is I want to verify that I can log in still, even though the homepage is incorrect. It's now something we would have to build out. So what I want to do is go into accounts/login and hit enter. Right away, I get this no reverse match. Now, why does this happen? Well, this happens for every single reason that makes Django hosts good and bad. So when it comes to reversing URLs, we just broke all of them. So whether that's inside of a template itself, so in the templates, we've got this URL hosts, or using something like Django reverse, the reverse URL function like reverse. Hopefully you might be familiar with that. But both of these things are now essentially broken. So you need to update all of them. The Django-hosts documentation does show you about this. So we've got inside of our host, here is how we actually have to handle that now. Then we can also override the URL tag and change it a little bit. Or we can also use the Django-hosts reverse wherever you might use reverse itself and have a default value of some kind, like host being www. So when it comes to the homepage, for example, if we go into our template here, we change this to hosts URLs, right? Or rather host URL, and we also need to load in hosts in here, right? And then we just pass in the host itself, whatever that might be. In our case, we have www as that host. So now we can go ahead and refresh on this page, and now it gives me reverse for home not found in other places, right? So it actually happens somewhere else. So one of the things we can still do is we can still use reverse itself, but our now Django, enterprise URLs need to have that reverse itself. So if I come in here and change this to simply home, the original URLs will now work, but they're going to be relative to that subdomain itself. So the next one of pricing just simply does not exist because the actual, URL routing doesn't have a pricing page. So we can come down here and look for that pricing page, which is this. So we can change this to host URL, and then our host being something like www. And then now our pricing exists. And now if I go into pricing, it should actually take me to that host URL, but of course it's not. So this comes back into Django itself as to one other thing we need to add, which is simply our default host now. This is yet another setting we want to bring in to our settings.py, and we're going to set in not just the default host, but the default parent host URL, which is this one right here. So we would do something like local host here. Right, so there we go. So now if I come back, let's go back here and go back a couple, refresh in here and go ahead and try to log in again with /accounts and log in, and then go into pricing. Now it gives me localhost pricing. So we probably need 8,000 here as the parent host. So back again and pricing again. And now we should see there's my local host, and now it's www. Okay, great. So that's actually really nice that it does that. One of the downsides of this, of course, is how my hosts do support localhost. Maybe you want that, maybe not. You could always use string substitution or bring in the actual host itself and do a bunch of other things as like, custom domain, all that. So feel free to do string substitution within settings.py where you might have your like, naked, or let's say, for instance, root domain without subdomain, and change that to being the string itself of localhost. And then you can obviously have environment variables in here to make sure that that part is working as well. That's not really the point. It's not really to learn everything about Django-hosts itself, but rather just to have our server be able to handle both scenarios, and then all of our template values, understanding that the actual reversing of those template values are quite a bit different now because we need to take that subdomain into account when we are reversing those URLs. We now want to automate the process of doing Neon branching. As a quick reminder, if we go into the Neon console and we take a look at our main branch, we can see all of the different tenant schemas that are in there, as well as the public one. All a branch does is a point-in-time backup of whatever you're trying to branch from. So in our case, we're going to go ahead and call it something like SaaS Migration. Let's just say SaaS Migration A, and it's taking the parent branch. I'm going to copy the name here for just a moment. We create a new branch, and at this time, there's a new branch, a new database URL connection string, but most importantly, this branch itself actually has a backup of all of that data from all of our schemas. Now, I want to prepare my project against accidentally messing up my migration process so that I can actually revert back to any of these given branches. And so when we want to revert back, we can always promote it. There's a lot of different ways on how we can promote it. We can, set it as the default. We can rename it as, new main or something like that if you are going through that migration process. Or, of course, we can always delete it. Now, when it comes to deleting these branches, we, of course, want to be careful we don't accidentally delete the main branch and delete all of our data. But the nice thing about branching is we can do this many, many times. And of course, if you upgrade your account, you can have even more branches that are available here. But even with only 10 branches, I say only as if it was like a small amount, having 10 branches will give us a lot of flexibility in terms of our migrations. So one of the things I did is I actually created a couple things for you for the code to actually run this, because it's a little bit straightforward in terms of how you set it up. So if you go to saasgorillas.com/code and you look into SRC and you go into the helpers here, you'll see Neon CTL or Neon Control. And inside of there's this client's functionality here. And this is actually also stored in a gist. The reason it's stored in a gist is so we can iterate on it. So if you need improvements, this is where you can go through and do that. The thing that this is doing is it's calling the Neon API. I would imagine at some point Neon will have a Python client dedicated to doing all of these things. But in the meantime, we can just use Python requests and some of our own stuff. So this part is fairly straightforward. Once we actually have that client in there, what we end up doing is we turn it into a database management command as well to just call that client. I'm just going to go over what's happening with that management command right now so you can just kind of see what it is that we want to call. So first and foremost, if we want to clear the migrations, the way I'm clearing these migrations is by using a prepended name, SaaS migrations, just like I did just a moment ago. The reason I do that prepended name is so I don't accidentally delete something else. So when we want to delete those old migrations, this is how that's going to happen, is you'll go through, look for that migration name as prepended to the actual name of the branch, and then it'll delete that branch. When we go to create a new branch, we use UUID 1 has a timestamp built into it. You could always have timestamps in here as well, but I just wanted to make sure that I have a timestamp in the branch name if I need to figure out when something was created, if for some reason I created two at almost the same time anyway. But the idea here is this command is very simple. It's just going to go ahead and run those migrations. So of course, to implement this, it's going to take a few things. So if we actually take a look at our code on VS Code, I actually downloaded and put these things in. I can actually see inside of the Neon CTL, I have a few settings related to Neon directly. So if I actually go into my .env file, I'm going to go ahead and bring these in for both the Neon API key as well as the project ID. So grabbing the API key and project ID are very straightforward. They are on the Neon console. These are also very useful if you want to create new database URLs as well. So if you end up doing the database per tenant instead of schema per tenant, using these two will make that also very easy. So let's go ahead and actually create an API key. We'll go into Neon. Then we're going to go ahead and jump on over into our account settings, into our API keys. We're going to create a brand new one. And this is going to be our SaaS, let's say SaaS migration or SaaS project. Let's SaaS Enterprise, something like that. All right, let's go ahead and create it. Grab this API token. We'll bring that in right there. You can always put quotes around it as well. Go ahead and save that. And now the reason we need the project ID, which of course we could get from the API token, but the reason we need this is so that when we go to do the branching, it actually branches based off of the correct project itself. So grabbing the project, you just go into settings under general. There's the project ID that you need. And of course, it's going to be unique to your specific project. Okay, great. So now that we've got this, what I want to do is I want to test out the new DB branch command that I created just to make sure that it is working. And so let's go ahead and jump into the project here, and I'll just do python manage.py, and we'll go ahead and do db branch and hit enter. And of course, this should give us something related to this. So right now, it's giving me a none on branches. So maybe I need to refresh my terminal session. That's probably what it is. Let me go ahead and do that. CD into SRC, run this again. Now it should actually give me the correct one, but it looks like I've got an incorrect setting. I actually know why. One of the things I skipped doing was, I put it in the env, but I actually did not add it into my Django settings. So let's go ahead and grab these into our settings. And I'm going to put it right above the database URL, because it's related, of course, to the database itself. And so here we go. And we've got our API key and our project ID. Now let's go ahead and give that a try. So it should actually give us the correct URL. Sure enough, it does. And there's our new branch. We could do it again, and it's going to go ahead and create a new branch right now. So of course, this is important for a number of reasons, and we'll actually automate it. But checking inside of the Neon console, we can see these branches in here, and you can also verify the tables, like going into any of the tables in there for that branch. You should be able to see all of that same data. It is wild how quick this ends up happening. Okay, so where is it that I really want to call this, though, is not so much as a one-off command, but rather inside of our tenant tasks. We're going to go ahead and put it in the migrate tenant task, and I'm going to go ahead and add in branch, and we'll say branch equals to true. And then basically all I'll do is before I run anything out there, I'll go ahead and say if branch, then we'll go ahead and do our call command, and this is going to be db branch, right? The reason we have this branch equals to true is because this is not the only place we call this tenant task. If we scroll on down here, the migrate tenant schemas, all of them, I'm going to go ahead and come down here and say branch equals to false. And then once again, call command and db branch. This is making sure that I actually do the branching basically all the time. Now, granted, if I have a bunch of different tenants coming in here, there might be some issues with too many branches. I would personally rather have too many branches than not enough, as in missing data in there. So let's go ahead and give this a shot with calling our migrate schema command. This should branch just the first one, right? So it should run in there. There's branching Neon, and there it goes. And then all of the migrations are done. And then, of course, if I go into the Django admin again, so if we jump into the admin, let's go ahead and make sure our server's running here to make sure we can. What should also happen is a branch being created there inside of the admin itself. So let's go ahead and jump into the tenants, and we'll go ahead and just save one of them and hit save and continue. And this, I believe, should call one of those branches, and sure enough, it does. So that might be a good example of maybe we do want to branch it, maybe not. Maybe if it's created, that's when we branch it, or something along those lines. But now we have the flexibility of when we want to run this migrate tenant task and whether or not we want to branch it in there, right? So like something down here. So like if we wanted to do created, basically something like this, being created is false, then we'll go ahead and say if not self.pk, then created is true. And then down here, we could then say something along the lines of branch being created, something along those lines. So the primary key will not be there if it's not created yet before it hits save, which of course there are some caveats to how well that's going to work. But the idea being that we want to have more branches than not enough. And once you actually have all these branches, you might want to revert them. You can see when they're last active, and then the actual name of the branch will help with when it was created, but you can also obviously see when it was created here, but more specifically the exact time. I don't know, you probably don't need it, but having the name in there for creation, I think is nice. Also to just make sure that it's definitely a unique schema migration. But now with all that, what we could do is we could then come in and just go into cd src source and then manage.py db branch, and then we called it --clear -migrations. And this is something we could do maybe daily if we need to, or just shortly after we run the migrations, just to make sure that we don't have too many in here. So again, we can always download them. We can do all sorts of things. Now, when it comes to going into production, I do recommend upgrading your account so that you can protect the main branch and you can set it as the default. Both of those things are highly recommended if you're going to go through this branching process. And of course, if you're going to go through actually doing these multi-tenant applications. Now, this automation process, I would imagine, is going to evolve over time in terms of migrations. But the point is to have some sort of strategy in place that you can actually go about doing this. Now we're going to take a look at a database per enterprise multi-tenant approach. This means that we have a unique database URL per enterprise that's going in, or per tenant that we have. I really just want to show you how you can migrate it and then use a database dynamically that's not hard-coded into any of the Django settings. That's really how you're going to start this process. Now, I think a lot of this is still very challenging, but you can use everything we did in the schema stuff to really use these dynamic URLs. So inside of Neon, we're going to go ahead and create a brand new project. I'm going to call this just simply SaaSDB2 or just simply SaaSDB. Up to you on how you want to call it. The region, I still want it to be close to me physically so the migrations happen quickly, and also adding all the data in as well. I'm going to go ahead and create this project, and I'm going to go ahead and copy the snippet here, and I'm going to bring it into my env, and I'm going to call this db URL like 2, something like that, and just paste that in. Now, do keep in mind, these are separate from each other. They are different databases, and we could actually keep track of these dynamic databases by using our Neon API key and the various project IDs. So there's a lot of things that we could do in there where we're managing the database project per enterprise if we want to go about doing that by having our own API key and all that. That's well outside the scope of this one. I really just wanted to show you the approach as to how you would use another URL like this. Now, traditionally speaking, if you wanted to have more than one database, you can actually open up your settings and create another database in here. So you could call this one your enterprise database, and this one could be responsible for all of your other database things. And of course, you would change this to that db2 URL. This is how you can actually use multiple databases inside of Django itself. Now, the way this works is going to be very similar to what we're about to do, except I'm basically setting this setting dynamically. I'm doing it when I need to do it. And so with that in mind, I'm going to leave my settings as is, and I'm just going to go ahead and jump into Commando. I'm going to go ahead and copy one of our previous commands of Migrate Schema, and this is going to be called Migrate Dynamic DB, just like that. Okay, so what is it that we need to do here? Well, first and foremost, I'm actually going to go ahead and do from decouple, we're going to import config. The reason for this is to help with the dynamicness of loading this URL instead of putting that URL in the settings. Again, if we were going to put that URL in the settings, we might as well add it as one of the configuration items in the database dictionary itself. So with this in mind, I'm going to go ahead and say my db URL equals to the config of that value, and I'll default it to none. And then we'll go ahead and say if db URL is none, then we'll go ahead and return. Otherwise, we just need to do the same sort of configuration. So something very similar to this right here, I'm going to go ahead and bring in to my project. Now, the point of this, though, is to not set all of the databases, but rather set an alias. So we would set an alias, and this will be something like db2, or you could do dynamic db2. And so this is going to be the alias for our settings, which we will pass in very similar to this, and I'll set it equal to almost this. We will talk about this in just a second. And of course, we are actually going to do settings dot. The reason we have settings dot is because after we actually configure the settings correctly, we're going to go ahead and just call our command of migrate and then actually pass in the database of that alias. So whatever that alias ends up being, we would do that. So this call command of migrate can work if the database setting is directly in settings.py as well. So it's not really doing a whole lot different than that. But before I go any further, what I want to do is I'll say my db, and we'll call it parsed config, is equal to almost dj database URL config, but it's a little bit different. I'm going to go ahead and import dj database URL, and then we're going to go ahead and call parse here instead. And I'm going to go ahead and pass in the URL itself. We don't need default anymore because we're not doing the configuration. We are now parsing it. The max connection age, I'll go ahead and get rid of that. The engine itself, I probably don't even need to change, but this is essentially what we're trying to do here. We want to parse that URL. We can see what this parsed data is. I recommend printing that out just so you can see what's happening there. And so now that we've got this, let's go ahead and try the migrations. I'm going to jump over into SRC. We're going to go ahead and run python manage.py, migrate dynamic db, hit enter, and we get an error, key error of time zone. We'll come back to that in just a moment, but I will scroll up to here's our database connections. Now, the point of this is to make sure that the host, the way this is decoupled, is correct. So you can always hard code these values. DJ database URL just kind of makes it a little bit more convenient for us, but we can hard code these whether they're in .env or they're stored in the database somewhere else, like the actual public database. So you could think of this as being something like, if we had a query set of tenant.objects.all, we could go ahead and grab an object being qs.first, And then we can think of our DB URL being equal to obj.db URL. And this, of course, would come from our default public DB. Something along those lines, right? So we've already seen how to do some of those things, but then we could just grab that URL here, and this would basically work through the same process. But the problem with this parsed config is we have some errors in here. So I'm going to go ahead and copy and paste a few additional configurations we need to have by default, which I had stored on the side over here. The first one we actually did see was the time zone setting. We want to grab that from our settings themselves, from whatever time zone it is, because we will set this in the database that we're migrating, and then a few other commands that you want to set by default. Now, all of these defaults might expand over time, and feel free to look at the documentation for that to make sure that they're working correctly. But now that we've got all this is now a dynamic database that's coming through. We can actually go ahead and run through the migrations, once again, just verifying some of the configuration that's coming through, but we can see that it's now migrating. And of course, we can also verify this by going into the Neon console for this other project and then just taking a look at the different tables in there. Now, the important thing to remember is this is going to just work in the public schema. Once again, this is not schema based. This is database server based, or the entire project based. And we can see all of that working through. Now, we could also use this to then create schemas as well if we wanted to do a super enterprise user that has their own enterprise customers as well. So like multi-tenant, that layer of, going through inception is a little bit complicated and probably outside the scope of something you're going to want to attempt before you do all the other schema stuff. But the cool thing about this is we now have the dynamic loading of a database and running that migration. Now, do keep in mind, this is not as robust as the schema one that we went through, that went through a bunch of things in terms of the migration, right? So if we actually take a look at the schema task and we look at all of these migrations, this, of course, is not happening on that single database. There would be a way to modify all of these things as well, but of course, that's well outside the scope of what I'm trying to do here. All I'm trying to do is run this migration and now taking a look at how we might use this dynamic URL in any given view so that we can actually try that out and see how we might approach doing that. So you can see how complicated it might get with this approach. Now that we've migrated that other database, I created this context manager that's very similar to what we've seen. So use dynamic database URL. What we've got here is we are going to get the database configuration. This time I'm using the default Postgres backend. Then we also see the time zone, all that sort of stuff. And then we have a few other options if we want to use a different schema than public, which I have the default one on there, which of course, if you end up using a different schema, you're going to have to connect it and make sure all of those things are going on. I do want my original configuration in here. Then I go ahead and try to change things. If that ends up finishing, then it goes back to the original configuration. So very similar to like what we did with our schemas, the use public schema or use the tenant schema. This is basically the same idea here. And I just want to show you an example of it. So the way I'm going to show you this example is by going into the landing page or the main homepage right here. So the point of this is to make sure that this is running. So let's go ahead and make sure that we actually can go to our landing page, whatever that might be, whether it's a dashboard or not. I just want to print out something like this is working, ... Save that. And let's go ahead and take a look at that page. And what we've got here is this is working. Great. So with this in mind, I want to bring in the helpers context here. So I'm going to go ahead and do from helpers.db. We're going to go ahead and import the context here of use dynamic database URL. Okay. So with that in mind, I'm also going to go ahead and do from decouple. We're going to go ahead and import config. And then I'll go ahead and reorganize these things a little bit. I still want page visit in there. I still want the same Django models all together. Okay, so the config is going to be our dynamic database URL, which we just called DB URL2. So let's go jump into our views here. And I'll go ahead and say DB URL2 equals to config of that, default being none. And then I'll go ahead and say if DB URL2 is not none, then we'll go ahead and do with use dynamic database URL here. And all I really need to pass in is the DB URL. Notice that we've got an alias and schema, but realistically, I just need to pass that portion in. So this is now going to use that other database. So the way I'm going to do it is by grabbing a query set and do pagevisit.objects.all. Now this is where the multi-use of Django comes in. So we actually want to declare our alias here, and I'm just going to call this alias db url2, and I want to pass that into this argument here, and we'll go ahead and pass in that alias. The reason for that is because when we do a query set with a non-standard or non-default URL, we need to pass in our using. We need to pass in the database that we're using now. This would be true if we dynamically were using the database. It would also be true if we hard-coded the database. So if inside of our settings there, we actually had another database in here and we said, db2, that would be how we would use it. We would go ahead and use using. We wouldn't need the manager. We would just need to make sure that we are using it. The reason that we have this manager here, this context manager, is so that that database is actually available during this block. That alias is actually available to it. And we just renamed it there. Great. So what I want to do here is I want to print out qs.count, and we'll go ahead and say something like the page visits and is qs.count. Okay. So the reason I'm also doing that is that I can come above this and grab that same thing. So in here, we'll take off using, and then I'm going to go ahead and working, and we'll go ahead and say print OG visits, and that's going to be qs.count as well. And we'll just go ahead and use some string substitution in here for that. So these should be two different numbers if we did this correctly. This actual landing page view is actually creating multiple page views as well, but it shouldn't actually affect this one. So once this with statement or this context manager is exited, it should go back to the default value. So let's go ahead and run this server once again and see if everything's working. We'll go back into our landing page. Notice the landing page shows you the visits, so it's at 20 now. And what we've got is OG visits being 86. So maybe if we actually take a look at our page visits, we've got our query set in here. It's certainly possible that we're getting some odd number that's related to this. I'm not sure why we're getting 86 up here when the actual query set count that we get, maybe it's the social views count. Maybe it's something related to these. So we can actually print that out again, and we'll just do the other QS visits, QS.count. Okay, and let's go ahead and take a look. And so we've got 87 coming through here, and then the other one being page visits there. And that's why. So we've got our dashboard view up here. So maybe the dashboard view is slightly different in terms of page counts. It probably is. And yeah, okay, cool. So it's actually showing the right numbers. I'm not sure why the dashboard's showing the incorrect ones, which of course we could go through the dashboard and take a look as to what's going on here. It's probably related, there we go, it's related to the requested user. There is that count. Okay, so we're going to kind of ignore the requested user for now. I just want to go ahead and do .all so that all of the numbers are showing up correctly wherever we end up seeing them. Okay, great. So this is my standard default database right there. If we go back into the view, all of that hopefully is very clear. But in here, the dynamic database URL, we see that page visits at 0. So this is quite literally showing us that, yeah, we're not actually storing any of those page visits. Now, the requested user, this particular user, is not in this database, so we don't actually want to mix and match those things. I'll just go ahead and say the user is none. I'll go ahead and save it, and now if I refresh in here, I should be able to get both instances coming through, and we should see some of that data coming through. But unfortunately, we do not, because not only do we need to change the user, but we also need to make sure that we're changing the database alias or the different database in there. Otherwise, it just simply won't create that data. And so now we see that it's actually creating page visits every time we go. So we go back into Neon, we look in the database in here, we refresh, we scroll on down to page visits. There's those 2 page visits. Fantastic. If I change it back to the other project, the other entire database URL, and going into public, going down into our page visits, this has far more visits in there altogether. So that is showing us the power of this one. It's actually working, and it's working correctly. And of course, if we look at the users in there, there's no users. Of course, there's no users. There's only page visits because that's all we've ever created with this particular project. To me, this is the approach that you'll want to take, very similarly to what we did before with the schema ones. It's still complicated. It's, I think, more complicated than the schema ones, but it is definitely approachable. I think a big part of the reason it's more complicated is because this is on a completely separate host. If you had thousands of other databases, or let's say 10 other databases that's a lot of database servers you need to manage versus the one single database server that you need to manage for the entire project, and then also individual schemas. This to me is quite a bit more complicated to set up. Hopefully what I just showed you is a good indication as to why. There's still a lot of things that are overlapping as to what makes it less complicated to set up thanks to Django's built-in features. So many of the built-in features that Django has make this a lot easier. So the parsing of the database itself and then setting the database and running the migrations, these commands right here make this process, I think, so much easier. And then of course, going back to thinking about if we had a lot of different databases, we could loop through all of them, run all of those migrations once again. Now, in the case of these multiple databases, the reason I actually probably wouldn't narrow down the installed apps is because I could just have different URLs to match on what I end up showing up, but all of the tables end up being the exact same. The only reason I showed you how to do the different URLs with the schemas was in the case that you wanted to do that. There's not that much of an overhead to have the exact same schema all across the board. In fact, it's probably a lot easier to manage if all of the schemas are the same so that you don't run into that situation where we saw before when we went into pricing where it said no table exists. Now, granted, we can still do the URL mapping with Django-hosts like we did, but having the exact same database tables, I think simplifies things a lot on whether it's the multi-database per enterprise or multi-schema, enterprise tenants and all that. But all of this is possible because of Postgres, because of Django, but it's made so much easier because Neon has the serverless at its core. So you're not actually charged for all of these instances unless they're being used all the time. You're only charged for what you store in those databases and then also all the compute you actually end up using, which I think is one of the biggest reasons to use Neon in this way, is because you have all of those advantageous things when it comes to managing your databases. Now, granted, if you start getting really, really big and you have a lot more tenants, then you might consider starting to use other database URLs. And of course, Postgres is Postgres. You could always use other database URLs in conjunction with what we've done here if you want to go that route. And of course, if you want to go pro tier, the whole thing would be managed directly through Neon and the Neon API key, including your standard Django database URL. That is outside the scope of this one, but hopefully now you have a really strong sense as to how to build a multi-tenant enterprise application, at least some of that foundation. I realize there's so much more work to be done to make this work really, really well. But of course, if you're going under that enterprise route, that is what you're going to have to do. So if you do have questions on this or you want to see more to how to build this thing out, please let me know in the comments. Hey, thanks so much for watching. Hopefully you got a lot out of this one. Now, if you're building an enterprise SaaS application and you're still struggling with multi-tenancy, whether it's schema-based in Postgres, whether it's using a dedicated database URL that's dynamically loaded, please let me know. I want to really help solve this problem. I believe that isolating your data from other customers or other users like multi-tenancy does is going to be incredibly critical as we start building out more and more AI systems. More companies or more individual users are going to want to have almost a dedicated database for their data, so there's no chance of overlap and perhaps even complete control over that database URL. So if you think about that dynamic loading of the databases inside of Django, I think that's going to become more and more important because you think of tools like Neon where you can spin up a database instantly and all of that data is available almost instantly as well. We're going to have to learn how to dynamically load that data in for our users and for our enterprises. So in many ways, this is really a foundation to understand how all of that works and also how to do it practically. Now, I think there's still a lot that you can do here. And of course, if you wanted to do the per database, per enterprise approach to building out a SaaS application, that is level 3. That is top tier. That's going to be the hardest thing you're going to undertake. I still really think that using Django users and Django groups is one of the best ways to start because you can still isolate data in that way that we loaded in that dynamic database URL. We can load in a dynamic database and then actually still run migrations or still insert data with raw SQL. And AI makes that a lot easier as well, which is also pretty cool. But thanks again for watching. I am very curious as to what you want to see next in terms of enterprise SaaS with Django, or maybe with Reflex or Fast API or any of the other Python applications, maybe even Node.js. Let me know what you think, and thanks again for watching, and I look forward to seeing you next time.